morning, folks. Thanks for joining in. This is Nipendra, and I welcome you for the KCD Bangaluru's first workshop, which we are starting today. And after this, we have many other workshops lined up to just kind of give you a complete flavor of the what you call the cloud native stuff, right? So we start with Kubernetes 101. Then we have lifecycle management for cloud native apps. Then Argo rollouts, which is CI/CD thing. Then for chaos engineering, then we'll have how do you deploy Istio, which is service mesh for you. Then we'll have a security workshops, and then multi-cloud Kubernetes lifecycle management. That's kind of a bit on the advanced side. So a few more workshops may come in between, so that we'll update. But the idea for these workshops in this order is that you'll have some time till the main event. And if you want to attend all of them, you can do it. So you can take this workshop, practice, come to the next one, and so on. So that is the whole intention of doing these workshops over the week, over these 4 to 6 weeks, whatever we have remaining there. So for this particular Kubernetes 101 workshop, as we know that, right, we are going to cover this agenda today. This is going to be very beginner focused. I just assume that you know a bit of containers and Docker, nothing about Kubernetes. So Kubernetes is going to start from very basic. Let me just show off hands. How many of you have worked on Kubernetes there? So, I mean, not so Docker. How many of you have worked on Docker earlier? Like, there's no one who's completely new to containers as well here. Well, let me ask another way. Anybody completely new to containers here? No, right? Please feel open. Please have open discussion. That's perfectly fine. Yeah. Okay, so I assume that.
I worked on basic setup of Docker and running a containers.
Come again?
With Kubernetes also. So I worked on basic setup, like setting up a Docker container, creating a container, and helping the team.
Okay.
So I have a basic knowledge.
That's okay. Basic is only what we are looking here, not much. So basically, what container is basically, you basically package your application and put them in a box, right? And then that particular box we call it as a container image. And from that image, we can create containers wherever we wish, right? That's the whole idea, that you take your application binary with dependency, put in a box or a package called image, and this runs same everywhere. This is going to save time for everybody as we use them in environments. Yeah. Okay, so I'll touch upon briefly, I think, in our Kubernetes 101 overview, like when we start the course there. So I just want to make sure that you have access to this particular page here. I am putting on the chat again. So this particular link, if you open up, you can sign up for our portal, and this will give you the access to our workshop, which will have the content and as well as the lab environment as well. So if you open this link, you can sign up for free here. You can click on this access course, and this will kind of bring you, not like this right now. This will give you a button here of lab setup. So I'll talk about that briefly. So just want to make sure that first of all of you are signed in to the portal here. Let me know if you're facing any issues in signing up for the portal. Done. Okay, great. Let's keep it very interactive. If you have any questions, please feel free to kind of just ask away. Don't wait for me to kind of finish a topic and ask. So whenever you feel like, please just ask the question. Yeah. So, okay, anybody, I assume that nobody is waiting now. So once you're in here, this particular platform has the content, as you can see here. We already have a pre-recorded content with the hands-on lab, what we'll be doing. Along with, there is the lab environment. So currently I see here OpenID, but as you have just joined in, you might have a button of lab setup, and you can choose the number of hours you want to have. So please choose for For 4 hours or 8 hours, you can do that and then do that. So you'll be given overall 40 hours, I believe. And you can choose for 8 hours right now or 4 hours. That would be okay. So once you have basically triggered the lab, so Karthik, you can do for the mobile as well. Our platform should will support that. Let me know if you have any issues there. I mean, you should will do that because what's happening in our, I'll show you actually. So once you are, once the lab is being triggered, right? What you'll be getting is you'll be getting a terminal like this, which would be having the terminal on which you can work on. And as you can basically look at our course curriculum here, right? Wherever we run the commands, right? You can basically, once the lab is being triggered here, you can access or run the commands, of course, by terminal, like the way I'm running any commands here, right? Or I can basically, there's a button in front of every command. You can click here and this would also run the command for you, right? So you can either do by the terminal, by the just hitting the command here like this, or there is an IDE also on which you can write YMLs and so on. So there are different ways to interact with the setup, and hope that will also sort the problem for Karthik as well if you want to just do it on the mobile as well. Okay, so we'll do with a very basic stuff, and then we'll jump into the topic, right? So before I start, I just want to introduce myself quickly, and then we'll kind of get going. So my name is Nipendra, and I'm founder of Cloudiga. Before starting Cloudiga in 2015, 2016, before that, I worked for over a decade in different companies, primarily with Red Hat. Have experience as support engineering, file system, kernel development, and perf engineering. In 2015, I wrote a book on Docker. And post that, I realized that this is going to change the way we develop and deploy the applications. And because I love teaching, that's why I thought of kind of move on and just try out with Cloudiga and see how I can do it. But since then, it's been going very good. So I kind of went back to the corporate job as of now. So Vebha just joined in. So Vebha, I'm giving a link on the chat. Please follow that. Sign in for the course and so on. Yeah. Then in 2017-18 timeframe, I also authored a course on Intro to Kubernetes with Linux Foundation. That course is now taken by more than 200,000 users across the world. So if you go to cncf.io, there they have kind of a public training on MIT's EDX platform. So if you look at this course, this is I authored that course for the first time. Then Chris is kind of working on that course to modify it and make it up to date. And I'm also a CNCF ambassador and running this KCD Bangalore event along with others as well. Okay, so that's a quick intro about myself. So just the whole session, what I just shared a link on the chat, I'm going to put it again. So if you are just joining, you can do that. So just sign in for the course there. Now in the course, once you come in, so in this course, we already have pre-embedded slides, content, and the hands-on labs. So what we'll do is if you just come in, you can trigger here the lab setup for 8 hours or for 4 hours. And then it will kind of bring up the environment like this, on which we would be able to kind of run any commands. And of course, these commands can also be executed from the terminal itself or from the terminal, as well as we can kind of do it from our platform itself. So as you kind of look at, there's a button of execution is there. So if you trigger the lab, then you should be able to run the commands just like this as well. Okay. So I think that's good. We'll now get going with our content, what we have come here for. So there is a quick video I have, which I would have you play a bit later, other than right now. So this basically talks about what is the why we need a container orchestrator. So if you have used Docker earlier, then with Docker, you could run containers on a single machine. Let's see if, yeah, so let me just talk about briefly what containers are, if that's okay. So traditionally, we have been deploying our applications on physical hardware. So we used to have hardware OS on that, and then we deploy our applications directly on that OS. Now, if any of the application fails, right, or have some kind of an issue, it can basically make our entire OS go bad, right? And my entire OS can fall apart. So that's a problem what we had in traditional system. Then, of course, in the last last 15 years and so, we kind of moved toward containerized or virtualization there. So what we did basically on our OS, we deployed a layer of hypervisor. And with the hypervisor, we could basically partition our underlying hardware into different chunks. So for example, I can say, I want to have an instance of 2 GB of RAM or 2 CPU system and so on. Suppose you have a 64 GB system overall hardware, but then you can create these different VMs with different sizes of CPU memory, and then you deploy your applications on top of that, right? So guest OS, it can be Linux, Windows, Mac, or whatever. You deploy that, and you deploy our application on top of that. But as you look at here, our intention was to run the application. The intention was not to run the VM, right? Now, what if I take this application and run directly on the OS what I have in such a way, this app by itself behaves as an independent entity. For example, my app has its own IP address, its own host name. So it kind of behaves as an independent entity. And that's what container is, right? So you take an application, package it, and run on the system, right? Now, why we want to move containers or use containers? See, at a high level, there are only two things which you want to do. We want to save time and money. That is both our public or both our personal life and what you call say office work as well, right? Because if we save time, all of those things matter, right? So how we save time with containers? Because so let's say you have been in a traditional app deployment cycle, you've seen that, right? Dev, QA, and operations, right? When developer develops something, QA would need to kind of test it, right? But if the QA takes a lot of time to just set up, it just waste of time for you. But when you move to containers, the same app what developed by developer would run on QA on prod environment. So your entire software lifecycle is reduced, and that's where we save time. We save money because suppose you could run, let's say, 10 VMs on hardware. Now you can run 50 of containers. I'm just giving a number there. 50 on the same machine, which is 50 apps you can run. That's going to save the money for you, correct? So that's how the main reason why you move to containers. Of course, then you have immutable infra, you build an image, all those things would come along with it. Now, containers are the feature of the underlying OS. It is not that Docker has come somewhere on the fly and just built everything, no. So our OS have the feature of basically resource isolation and resource allocation. For example, I want to give every program its own IP address host name that we get from the feature of namespaces. When I say I want to allocate 2 GB of RAM to a program, the CPU to a program, and so on, right? That covers a C group. So this is how the container features come into existence. Now there are different ways by which you can connect to your OS and request these, correct? So Docker, you can think of is one of the way, but there are many other ways using which you can do that. That is, we call as a runtime. So container runtime is a way using which you basically connect with an underlying OS and create the containers for you, right? But then when you create these containers, what we saw here, this container is running only on a single host, right? So this is running on a single host. Now, if this host dies, right, for whatever reason, maybe kernel got corrupted and power gone, power went down and so on, your all the applications are also gone. Correct. That is the issue with a single node multi-container setup and so on. And that's where we need some kind of an orchestration where we can connect multiple nodes together and form a cluster so that we can deploy our containers at scale. Make sense? Any questions so far? I said that, right? You don't have to kind of wait for till the last moment. Whenever you have a question, please ask.
Means what is hypervisor means?
Hypervisor KVM, VirtualBox, right? Which kind of VMware, right? Like VMware ECX, right? That kind of emulates your hardware, right? That's a hypervisor.
So one question here. Can you hear me?
Yeah, very much.
Nabindra, I mean, I understand about the Dockers, a Docker Rancher. They have a facility that they can have multiple containers of multiple nodes. Am I right? So why there is a need of
just a minute? So by itself, if you just talk about Docker, right? By itself, just a Docker binary is not. Once you configure Docker Swarm, then they'll form a cluster. Similarly with Rancher, a single node Rancher is as what we're saying a single node Docker as well. Only when you connect these multiple Rancher hosts, they form a cluster. Yeah, go ahead.
Sir, if a Docker Swarm was very enriched in their functionality, what was the need of bringing the Kubernetes in the world?
Yeah, sure. I'll answer that question in a few minutes. I'll just give me a few minutes. I'll answer that. Yeah.
Yes,
any other questions? Okay. Now, I said that, right? If you have these containers on a single host, and if the host dies, everything just go haywire, right? That's where we need some kind of an orchestrator where I can connect these multiple nodes. So those nodes can be VMs, physical machines, or any computer in general. And if we form a cluster to run our containers at scale. So basically think about, we take 4 VMs, we put them together with the help of software like Kubernetes, and then we deploy our apps on that. By doing that, we are going to get the features which are listed here on the screen. So some of them, not all of them, but there's some of the things what we have listed here. Let's quickly go over what I mean by each one of them, right? First of all, container provisioning. So when you deploy a cluster, you don't talk to us individual nodes saying that, okay, deploy my applications, right? So let me just quickly draw it. That would kind of picturize it in a better way. So assume that I have these 4 nodes, right? And I will basically kind of connect these nodes together and form a cluster. So now in this cluster, I'm just giving an example here. One of the nodes is the control plane node, while other nodes are your worker machines, right? So I'll talk about what control node and so on in a few minutes. But for now, just say this is a control machine, control plane. And others are your nodes, like a typical worker nodes for deploying the application, right? So what we have taken is, we have taken these multiple nodes together and form a cluster, correct? Now here, let me go back. Yeah. So I talk about container provisioning first of all, right? So what I'm saying is, I'm not going to communicate to the individual node deploy the application node. I would basically, so if I am an end user who deploys the application, correct? I would basically send my request to the control plane node, and this control plane node would be deploying my applications on behalf of me on different nodes there. Okay. Second thing is fault tolerance. Now, if one of the node dies in that cluster, automatically the application running on that node would move somewhere else. What I'm saying is, if this node dies, automatically the apps running on that node move somewhere. That is a node level fault tolerance. Similarly, if a single app has that for whatever reason, a replacement copy of that would come up as well. That is the app level fault tolerance what we have. Then we can do scaling, which can be both automatic and manual. So when you want to deploy applications at a scale, right, your traffic is coming up more and you want to scale it up. So now there, either you can do manual scaling, like manually say, okay, now my load is coming up, I scale up, or you can configure some kind of an automation, right, when you see that, okay, the request per second has gone beyond something, I want to scale it up, right? So this scaling, again, you can do both app level and node level. Then service discovery means that because when you deploy these applications, right, these applications will be deployed as a group or as a multiple replication, right? You don't deploy, you deploy the single replica as well, but when you scale it up, you're going to run multiple copies of the same application on different machines, right? Or anywhere in the cluster. So how would you kind of refer them by a common name, right? So for example, if you open a website, let's say google.com, right? Google would be getting served by multiple VMs or nodes behind the scene. But for you, it's just a google.com. So similarly here, we need somewhere where we deploy multiple replicas of our applications. I want somebody to refer them as a common name. So that is what service discovery is. Again, we'll dig deep into it. Then we have a different strategy of deployment. So when you move your app from one to another version, right? Today you are running version V1 of, you want to move to V2. Then you want to say that, okay, I would want to move to V2 only if V2 is 20% faster, or I want to update on a rolling basis. I suppose I'm running 100 copies of my applications, right? And I can't just bring down all 100 at once and then create new ones, right? I want to do a rolling update. I would bring down few of them up and then bring new one up and so on. So this is again a feature which you'll get with orchestration. Then we have based on story orchestration means that when you create these applications or containers, right? These are temporary, right? Because they'll not have any volume or any content, right? Which is stored for them permanently. So I need some kind of a volume management so that my data is stored outside, and if my container moves from one node to another node, I would move my data as well. So what I'm trying to convey here, suppose you have a storage, which is some public storage you have, and currently the storage attached to this particular container, for example, right? Now this container dies here and comes on other machine, right? So I want to make sure that this storage is moving along with me. That is what I mean by the storage orchestration. So I need all of these features to be in production, correct? Any comments here or any questions? All okay? Okay, great. So now there are different softwares which can do the orchestration for you. These are your Docker Swarm, Kubernetes, Amazon ECS, or HashiCorp Nomad. So these are different tooling which have built around to kind of give you all those features. But of course, they have some distinguished feature, which is some of them are just for themselves itself, or just for unique for themselves, right? For example, Amazon ECS would only work on Amazon, right? This is good for the Amazon ecosystem, but it is not good for me and you who don't want to go on Amazon ecosystem, for example, right? So ECS is built for Amazon specifically, right? Docker Swarm was built on top of Docker, but it lacks the feature which was needed to do a real prod environments, and then there were a lot of issues in between. So there's the concept of Kubernetes pod, which was very fundamental, which I'm going to explain, that changes the way you deploy the applications on the cluster, right? So that is what Kubernetes got it, but not Docker Swarm. So those kind of things which when you look at in detail, right, you will feel that Docker Swarm lacked those kind of features and understanding which was needed for production environment. And that's where Docker Swarm did not get enough attention. While HashiCorp Nomad is a really good product from the HashiCorp team, and this is going to do very well for our regular app deployments and upscaling and so on. But where Kubernetes wins on top of Nomad is that I can extend Kubernetes the way I would wish to. So there are ways by which you can extend Kubernetes for your own work, for your customization, right? So that extensibility is at a great level in Kubernetes. And of course, that kind of made it very much popular and adaptable to different platforms. So that's where Kubernetes kind of won the war there, and then it is now the leading orchestration engine for you. Correct. Also, the project by itself, right? It has come from Google. So Google has been running containers from 2008 onwards, and they have been using internally called Borg. So Borg is their project, which was they run internally, and they had experienced what it means to run containers at scale and in production. So when they saw that Docker is becoming popular for app deployment purpose, the next thing is to deploy on production. And Docker was at that point of time was not ready for, or not was built for the orchestration engine, because Docker Swarm has not come by then. So that's when the Google open source project called Kubernetes, and some of the Google engineers found a project, and then companies like Red Hat, IBM, and so on start contributing to that project. And eventually, what happened is this project, along with the trademark change to, or ownership change to the community, it has come under the Linux Foundation. So Linux Foundation, I believe all of you know what Linux Foundation is. It is like the foundation which kind of governs the roadmap of Linux down the line and so on, right? So future, present, and what is comes under Linux Foundation umbrella. Under that, the CNCF Foundation was found, and this kind of now owns the officially the Kubernetes project by itself. So if you look at the CNCF, first of all, there are many members to these foundations, which kind of help to basically run this particular governance of this foundation here. So there are different members like Platinum, Gold, and Silver members, and we are also a silver member in this foundation. Now, this foundation gives the common ground to the different projects which are in the ecosystem. So, for example, let's say you built some project for yourself in the company, for let's say which kind of makes database running very easy on Kubernetes, for example, and you want it to be adoptable by others as well. But as an individual, as a company, you might find it difficult to make it marketable and find out by adoption there. So what happens, you can come to the CNCF Foundation and come to the sandbox stage. If you like, they like it, if the community likes it, then you kind of go to the stage of incubation and graduated. So this is how the project kind of move to different categories, so that they kind of get adopted in different levels, right? So if something is graduated, which means it is like well adopted and you can scale it up as much as you can. Then CNCF give different trainings and all that stuff as well. So that I'll just skip here. As I talked about, yeah. So Kubernetes can run everywhere, be it on your laptop, be it on a public cloud, private cloud. So Kubernetes can be run everywhere because the way it has been designed. So it has something called as an API. So we have the Kubernetes API server, which I'll talk about later. So we communicate to this API server to perform any operations. And that API is going to be common irrespective of which environment you are in, correct? Which means you would not be bound to a given cloud provider. For example, let's say you were on AWS or whatever, right? You know, on AWS, and you built everything around AWS, but for whatever reason you want to move to, let's say, Azure, right? Now, typically, because if you're bound by completely on AWS, it's very difficult to move from one to another cloud. But if you're on top of, let's say, Kubernetes, right, it's going to be same everywhere. So migration and everything would become very easy. So it kind of become a vendor neutral thing where you can easily migrate between the clouds, or you can have set up with multi-cloud and all that stuff, right? That's where Kubernetes shines there. So it can run everywhere. It is very stable at core. So Kubernetes is very stable, very minimal at the core, but you can also extend it for whatever your needs are. So like different companies are publishing their projects or their software on top of Kubernetes for Kubernetes as a CRDs, which you call them, to extend Kubernetes for the requirement of the specific requirement there. It is very much suited for hybrid setup. So for example, if you have on-prem setup and on-cloud setup, because again, the APIs are same, you can have the private setup with less number of nodes. Only on demand, you can go on the cloud. So that's where you can save very good amount of money if you go to hybrid setup. This is what a high level is, why Kubernetes is. Any questions here? Okay, just want to check. Anybody having any issue with the lab setup? No, right?
So,
Go ahead.
So Nitin, just a quick question. Can you hear me?
Yeah, I can hear you.
Yeah, okay. So a couple of things. I mean, one another basic question. I mean, related to this, like when you started with, like in a single machine, we are able to virtualize and like using like hypervisor or like different tools to. Like,
Correct.
you are thinking about like a device has an IP, right? Like I mean, how does that networking happens? Like how does that we are able to provide public IPs for different VMs? Like, can you just little touch base on that?
Public. So see, again, so there are different ways to uh, give VMs public IPs, or we can give by the node as well. So if you go talk about VMware or any other thing, right? There are tools available using which you can, first of all, you can attach a complete network to a VM instance, right? That is possibilities there. Correct. And then, of course, just the network layer, right? You can take it out. So there are different specialized hardwares are available that can basically give your VMs a public IP as well. So those are, I think, pretty much well-defined things are there. So those are, I mean, this solve problem in the VM in the world of virtualization there.
Yeah. Okay. Okay. Got it. So another one, like you were mentioning about the different orchestrators, right? Like I mean, I
Correct.
also come up with this Mesosphere
Sure.
or
So Mesosphere was there. Now, if you look at, they have moved to Kubernetes as well. So of course they were very good at a time frame, but now they have moved to the different things. Yeah.
Okay.
Yeah.
Okay. Thanks.
Napinder sir, one question here.
Yeah. Go ahead.
It was a very great question which Karthik bring in. So when he's mentioning about how the hypervisor VM gonna have an access to the node or the cluster, are we referring here to the Kubernetes CNI, which is the network plugin, or are we referring to the default network which has been set up when we by default have a Docker been installed?
So there are two things he asked, right? First of all, I believe he just asked about how would VMs get the IP address, right? So
Yes, sir.
so VMs are independent of containers, right? You install VMware and you deploy VMs on that, right?
Yes, sir.
Or you deploy KVM and deploy VMs on that. So
Yes,
for
sir.
that purpose, as I said, that right, the Gopi is saying the NSX, right, kind of a solution there, right? So that gives the IP address to your VMs, which can be publicly addressable. Correct.
Yes, sir.
Now, when I talk about Kubernetes terms, we'll deploy these apps. We'll call them pods. And for pods, I'll go touch upon that how we can do the networking part for that. So that's a different story. So that's a CNI way. And so, okay, let me go back here. So now here we had different containers running on different machines. Now, these containers within the cluster, they'll have a private IP and they are addressable within the network itself. Correct. And that's where we'll talk about CNI. The CNI help in that scenario where you are connecting the containers of different hosts. Correct. So that is two different things. One is talking about VMs, talking about containers. So in containers, in a very minimal setup or a very basic requirement setup, you need to have some kind of a plugin using which I can connect the containers of different hosts. That we call it as CNI plugins. And there are different drivers like Calico, Cilium, and so on, which would be there. Okay, I think I'll come back to that questions or answer in a detail after I talked about a few more basic stuff there.
Thank you, sir.
Okay. Okay. All good. Okay, so we'll get going. So now we'll touch upon the Kubernetes architecture here. Okay. So now, again, I said that, right? We need an orchestrator which will need one or multiple nodes together to form a cluster. So here we'll take the example of there are, let's say, 4 VMs or 4 physical machines, which we basically consider as our nodes. Right now, with those nodes, I'm just going to create a cluster. Now, in this particular environment, one of the node is a control plane node, while remaining 3 are your worker machines or worker nodes are there. On the control plane node, we have components like API server, controller, scheduler, and something called as key values. So I'll talk about that. This is there to store your cluster state. On every node, we have a kubelet, kubeproxies, and few more stuff as we look them later. As a cluster administrator or as a app deployer, I'm going to communicate to my control plane to say that, okay, deploy the applications for me and so on. So let's look at the workflow here. So suppose I am a app deployer and I say that go ahead and deploy an application for me. So deploy, let's say 3 copies of an app for me. That's the request sent by my app deployer. The application request comes in to the control plane node by the API server. So first of all, if you look at here in the API server, it is the main communication agent with everybody, right? As an end user, I am talking to the API server. With the control plane, I talk to the scheduler controller with the API server. Key value store, API server. Every node, API server. So API server is the main communication agent for you. Okay. So we are sending a request to deploy 3 copies of an app for me. That request has come to the API server. Now I need to somewhere store that information in persistent way. And for that purpose, we have something called as key value store. So key value store is a place where you store your cluster state, right? Or what is the desired state you want to be in. That's getting stored in the key value store, which is like a brain of a system. And this key value store can be part of the cluster or can be outside of the cluster. So it can be anywhere as long as my API server can communicate to it. Okay. So this is the place where I'm saying that, okay, I got a request to deploy 3 copies of a given app. Now that request would be sent to the scheduler where it would tell you where those apps need to be deployed, because scheduler knows how many nodes you have in the cluster, what is the configuration, what apps deployed earlier. So it has a control of or kind of knowledge about the resource consumption and utilization there. So based on that, again, we will send the request to the API server. API server would then say, go and deploy this app on a given node. So assuming that we said that 3 copies of my app, then we got a request to the API server scheduler, and we said now deploy 1 copy on, let's say, node 1 and 2 copies on node 2, for example. So API server would communicate with the kubelet of individual nodes and say deploy 1 copy here and 2 copy of the apps here. Now, once my app get deployed, I would need to make sure that they are running all the time, correct? So for example, if one of the app dies for whatever reason, then I need to kind of bring it one more up, right? Because my desired state was 3. I said, deploy 3 copies for me in the beginning. That has been saved now. Now the controller is one which is responsible to make sure that at any point of time, my desired and the current states are matching. Okay. So if I said that, okay, deploy 2 copies for me, correct? Or deploy 3 copies of the app for me, right? I want to make sure that at any point of time, all 3 copies are running. That is what controller makes sure. Controller basically make sure that at any point of time, your entire cluster's desired state and current states are matching. Otherwise, it will try to bring into the state which is desired state there. So controller is make sure that all the apps are up and running, correct? Then once my app get deployed, then we have these kube proxies. This is going to allow the external traffic to come inside the cluster. That is what kube proxy is going to help me do, from where I get the traffic from the external world to the internal environment and internal cluster here. It does more job, which I'll explain it later. But for now, kube proxy is there to get the external traffic come inside the cluster. Any questions so far?
I have a question on the, so if you, like, for example, you mentioned that I need to deploy 3 apps and one app has failed or died, that particular information will be communicated to the API server, and then that will be communicated to the controller, because controller doesn't know anything what is happening with the app. So how, and once, yeah, so that part of communication, if you can just explain a little bit now, or if...
Yeah, I just kind of simplified a bit. So first of all, there would be some kind of a health check that would be happening in between. So if, for example, if a container fails just for the health reason, right? Like, so within the app, there is a health check. That is what Kubernetes will take care of it. That okay, one of the app is failing. Let me try to restart it here. So that is going to happen within the node itself, right? But of course, when the given application has died completely, for example, if this node has gone complete out, right? Suppose this node has a power failure, correct? So on this node, you would be running few applications, which I know from the API, from the key value store, that what apps are running on that particular node, right? And those kind of information, along with the controller doing the check whether the right number of apps are running or not. Again, this check again going to happen by the API server only, whether the right number of apps are running at any point of time or not. And if they're not matching, correct? Then again, the API will talk to the scheduler again, saying that deploy the applications again to make sure that they are coming in the right state there. So this is basically in a way that will just check whether the states are matching or not. It cannot do more than that. For the remaining stuff, we'll again have to kind of go to the same state of AP7 scheduler there. Make sense?
Yeah. And one more thing, that the key value store will only be updated once when you deploy the app. And if the request doesn't come like, okay, fine, now I want to deploy 2 more apps, then the key value store will always remain 3. And at any point in time, if any application fails, then the API server will keep deploying the application to make sure that the numbers match.
Correct. So key value store just stores the cluster state, what desired state you want to be in, and among with many other cluster state, like what are the app configuration there, what are the secrets I have, and so on. That is also go in the key value store. So this key value store is part of the cluster, or it can be outside. So like here we are talking about, there's software called etcd, etcd, which we typically deploy with Kubernetes to enable the key value store, but can be any other software as well, as long as my API server can communicate to over HTTP and do get, put, kind of those kind of operations there. So here in this key value store, we'll be having one leader and multiple follower. So of course, I can have a single node as well of the key value store, but that is not for production environment. In prod environment, I would have multiple replicas of my key value store running. So we have, like in this case, we see there's a 5-node setup of the key value store. There is a one leader using which I would do all the writes. The read can happen from anywhere. So if I have multiple nodes in my key value store, like in this case, so in this case, I can lose up to 2 nodes and I still have the quorum, right? So depending on how much high availability you would need, you would have 3 or 5 nodes kind of thing in your cluster, correct? Any questions?
It's going to be a very lame question, sir. When I'm talking about key value store, I'm being referring to my etcd. So can I have etcd on a physical machine rather than having on a cluster?
Yeah. So I don't have a diagram here, but I'll show you from one of the hands-on lab what we have. Yeah. So you basically deploy the key value store, which can be part of the node itself. Like there we have a node cluster, and my key value store can be part of my nodes, right? Or these can be outside. As I said that, right? My key value store can be inside or outside of my nodes. So I can choose to deploy the way I would wish. And in prod environment, we have seen that we choose to deploy it outside of the cluster nodes.
But it's just, I need to ensure that APIs have been happening.
Yes, you need to make sure that the APIs need to communicate with the key value store. That's the main part.
And so same for the worker nodes. Can I have my worker nodes rather than having on a cloud on my physical machine, but it's only on the same subnet?
Yeah, you can.
Thank you, sir.
Yeah, so let's go back here. So let's talk about a few more things here. Now here I'm talking about, there is a single control plane node, but as I showed in the other diagram, right? Even in that case, I can have my multiple control plane nodes, right? So rather than just having a single node where only one of my node is there to control the cluster, I have highly availability of my control plane node as well. That would be much better for me for prod environments. Similarly, now let's say even in a single node cluster, let's say if one of my node goes down, or not the worker node, let's say even in this case, my master node goes down, what's going to happen? Okay. Even in this case, if my master node goes down, my customers are not going to have a downtime. So customer directly do my application access via the node itself. So customers are not accessing my website via the control plane node. No, my apps are deployed on my nodes, and queue proxies are basically allowing me to get the traffic from the external to internal world, and there are many other ways as well. So when my customer accesses my website, they access via the node itself. Okay. So if master node goes down for a while, I'm perfectly fine. I don't have a downtime. I just need to make sure that I bring up my master node again. What I cannot do when my master node is not available, I cannot change my cluster state. I cannot deploy more apps and so on. But whatever is running, I'm still okay for a while. Okay.
One question, sir. Sorry, it came to me for interview. So if my master has been down, definitely the provisioning will not happen.
Correct.
Even the fault tolerance will not been happening, sir.
Fault tolerance for the nodes, right?
Yes, sir.
Yeah, that's going to be affected. Yes.
But my existing virtual machine still be connected. I will be have but orchestration will be impacted for the meantime, sir.
Correct. Yeah.
Thank you, sir.
That's fine. Yeah. Okay.
I have a quick question. Like, so you mentioned about the high availability, right? So if your master node is down, I mean, we still will have the replicas of that node, right? So that will take the control, right?
If you have a control plane highly available mode configuration, yes, then there's of course.
Which will be the case in any scenario, right? I mean, even in a production environment, there won't be one master node. So I'm assuming until all the master nodes are down, you will still have that is the worst case scenario where you will not have any provisioning done because all your master nodes are down. But in most cases, there will be a way to provision through the other master node.
No, so you need a quorum there, right? So for example, see, depending on how you have configured your key value store. Sorry, let me just go back here. See, if your key value store is part of the nodes, right, then you would need at least 2 of them to be up to make sure your HTD is in a highly available state. Are you getting my point? Correct? Because you cannot have the HTD running in silos. They have to, at least 2 of them have to be in quorum to make sure that I can write something. Correct? In this case, I would need minimum 2 of them to be up. While in this case, where I have the HTD outside my cluster, right? Even if one of the node is there, I'm perfectly fine. Correct? Hope that makes sense. So it depends on how do you configure. There are, of course, many things will go down the line as you kind of start configuring.
Okay.
But Nipendra sir, as in one understanding, so when we create a GKA cluster, or when we create a AKS or EKS cluster, we only get an access to the worker nodes.
Correct.
We never know where the master has been there.
Correct.
So what platform
they'll basically take the responsibility of that, right? They would have configured highly available control plane node behind the scene, right? And they may also take the backup of HTTP in regular intervals. So even if node goes down altogether, I have HTTP backup, I can replay it. Correct. So there are, of course, different things to do in the back end. But at the same time, because they are charging you, they'll take care of the things by even having multiple nodes or doing the backup of HCD, which they can replay it on the fly and so on. Because see, my state of the cluster is the key value store, right? If I have the backup of that, I'm perfectly fine.
I mean, that's what the reason is that taking a backup of HCD is really difficult. I tried 2 times, it really failed for me.
No, it's not difficult. It's just that you just need to follow the procedure, right? Yeah, that's it.
Thank you, sir.
Okay, I think we'll move on now. So discussing about, so let's kind of dig deep further into each of these. So talked about API server, I think we covered most of the stuff here. API server also handles who can log in and what they can do in the cluster. That is also part of the API server here. Key value store stores the cluster state for me. And primarily we are using HTTP for that, but it can be any other tool as long as API server can communicate to them. Controller makes sure that at any point of time its states are matching, and there are built-in controllers into it. So it's like single binary, but it has multiple controllers built into it, which are responsible for doing the node management. Like I have the right number of nodes or not. I have the right number of apps running or not, right? I have the right endpoints for my services. So these things are part of bundle to single binary, but at a high level, it's making sure that at any point of time, the states of the clusters are matching. Then your scheduler, which schedules our applications based on some resource constraints, whatever you may have given. So for example, I want to deploy my application with minimum 2 GB of RAM, or deploy my node where I have a hardware of GPU. So all those things can be configured as a requirement, and my scheduler will try to fulfill them to deploy my applications on the respective nodes. So when I do this scheduling, I do two things there. I first find the feasible nodes and do a scoring of that. So what I mean by feasible nodes, suppose you have a cluster of 20 nodes, 10 of them are Windows, 10 of them are Linux. So when you deploy your Linux app, you want to deploy on Linux machines, right? So you would say, I would find first feasible nodes. So I'll say out of 20, 10 are feasible nodes. Then I'll do a scoring of individual nodes, or it will run behind the scene for me. But best scored node would be used for my scheduling purpose. This is how we'll schedule our application on the cluster. Any questions? Okay. Next is we would then talk about a bit on the nodes here. So here, on every node, we have a component called kubelet, which is talking to my API server. We have the kube proxy, which allows me the traffic to come inside the cluster. And one more job it will do, I'll talk about later. Then we have a container runtime on individual nodes. So we would run containers on each node, right? So for that purpose, we would require a runtime, which can be like containerd, cr-o, Kata containers, Docker. There are many more. So you deploy a container runtime on every node, and then we deploy our applications on that. And in Kubernetes, the apps get deployed in terms of pod. So the minimum deployable unit on Kubernetes is called pod, and pod is the collection of one or more containers. So like as you can see here, in this we have a pod with single container, or we have a pod with multiple containers. Okay. So when pod get deployed, they get deployed, or it get deployed completely on a given node. So you cannot say half of the pod goes on node 1, half pod goes on another node. No. A pod get deployed completely on a given node. Okay. Let's understand a bit more on this pod terminology here, because very important to understand. So when you deploy the pod, I mentioned that pod is a collection of one or more containers, right? So if I talk about the pod here, so let's talk about this is my pod here. In this pod, I have a container 1 and container 2. So let me just do that. Container C1, container C2, right? Now, in a pod, these containers shares the same network namespace, which means they are going to be a single IP per pod, right? So suppose I give an IP here, 192.168, whatever it is. This is my IP to my pod here. Now, depending on the port number, I am listening, or my container is listening on. Suppose container C1 is serving on port 80, while C2 is serving on port 8080. So if I hit the pod's IP on port 80, the C1 responds back. And if I hit the pod's IP on port 8080, C2 responds back. Okay. So this is how it is. So you have a pod in which you can have one or more containers. If you have multiple containers, they'll share the same network namespace. Between themselves, they'll communicate over localhost. So for example, if C1 want to talk to C2, it says C1 localhost 8080, right? And vice versa, right? This is how they are going to communicate between the containers of the same host, right? Hope this makes sense. So assuming that if I ask you to deploy a container of WordPress, right? And if I ask you to deploy MySQL in this, and WordPress here. Assume that, right? Now, this is definitely possible, right? I can deploy, I have a pod. In this pod, I can deploy a container of MySQL and a container of WordPress, right? My question to you is, would this be a good approach or not? Answer on the chat, yes or no on the chat. If I have a pod which can have multiple containers, I would will deploy MySQL and WordPress together. My question to you is, would it be a good approach or not? Yes, Gaganpreet says yes. What about others? Okay, assuming that remaining all of saying yes. Anybody for no? Okay, so this is possible, but not a good approach. It is not a good approach. Why? See, for example, here, when I'm deploying these applications, right, I have picked up my WordPress and deployed like this. Now, suppose this, if I just want to scale my front end, right, by virtue of having in the pod, right, I cannot independently scale the front end itself. I have to scale both back end and front end here, which is a challenging for me, right? Because I don't want, what my need was to scale only front end. But now because we have clubbed them together, they have become a unit, right? So if I deploy, if I scale in terms of pod in Kubernetes, right? Which means unnecessarily I have scaled my database, which I didn't intend to do it, right? So this is not a good approach to deploy two these kind of apps together in the same pod. Okay, it's not a good approach, right?
I mean, very good example, but I'm not little clear about it. When you said we can proceed with the solution, but it's not a best practice.
Yes, correct.
Am I right? And
Yeah,
you said
correct.
something after that we go ahead and do a scaling on the pod level.
Correct.
That's something which I'm missing. That's something I need to
pod
understand.
is a basic deployment unit, correct? So when you work on Kubernetes, the pod is a unit which you work in, right?
Yes, sir.
So you have to scale by the pod basis, right? So because here your pod contains two containers, right? Both have to be scaled together, or both have, you get a copy of the pod itself, right?
Yes, sir. Got it. High horizontal scaling and vertical scaling concept.
Whatever it is, right? Because pod is a unit, right? If you scale the unit, you get both things, right? It's a unit for you.
So you can't go ahead and scale the container individually. You're gonna go ahead and scale the pod.
We can do that if they're part different pods, right? That's why when you deploy these microservices, right? That's why we want to kind of partition them in a way that they are complete by themselves, correct? So here they are two independent components, right? Better deploy them in two different ways. Correct?
Sir, in case, let me put an example. In case we have Redis, which has been here.
Sure. Okay, I got a question. Let me just answer that. I know that what you're trying to ask. So sorry to kind of cut you short here. I just want to kind of make sure that we have a good momentum here to finish on time. Don't take me otherwise, Gagandeep. Please.
No, I'm definitely going to connect with the offline with you for my CKD preparation.
Sure. Okay. No, that's okay. Okay, fine. So let's to kind of do that. So now this is not a good approach, right? Then what is a good approach? So currently what we saw here, it is not a good approach of deploying a multi-container pod. Then what is a good approach? Because a pod can have one or more containers. Now, let's say you have a use case here. So again, let me deploy a pod app here. So suppose again you are deploying a pod here. Now in this pod, let's say you have an app, which is, let's say a web server called Nginx, correct? This is currently serving some HTML pages, which are part of your, this is some folder here, right? This is serving your HTML content and it is getting served to your audience, whatever, right? It's perfectly fine. But now I tell you that I want you to sync up this HTML content in every half an hour, right? Now, how would you achieve this, right? Now, one way to achieve this is you modify the Docker file of Nginx and build an image again, which would hard code this mapping for you that every half an hour sync up. But that's not going to be a very good solution because what if I change you a different location or different time frame and so on? What I'll do here is I would basically bring up one more container here, correct? And that container is responsible for doing the syncing for me, correct? This syncs every half an hour for me, correct? This is what we refer as something called a sidecar container, which are doing some complementary job for you. Okay, there's one primary app There's a sidecar container which is doing complementary job for you. Other thing can be you kind of write logs here, right? These logs would be sent by the sidecar to the log server, correct? So this is a use case of a multi-container pod where you are doing a complementary job. Maybe it's the caching you're talking about, right? You want to put a Redis cache, that can be a sidecar, correct?
Yes, sir.
So those kind of things are ways. So they are not an independent app. They are somehow complementing my work or job for me, correct? So that is the right use case of a multi-container pod here.
But in an ideal form in a production environment, rather than this sidecar requirement, we don't use a multi containers.
Yeah, you don't have to unless needed, right?
And that comes in an idea that there's no point of having microservices. Am I right, sir?
Come again.
If that comes in an idea, I mean, except sidecar. If we are putting all, if we are putting the previous example,
there's no point, right? Yeah.
Point. Yes, sir.
Okay, so that's there. So now this pods configuration file, I can give it to Kubelet in a JSON or a YML format. So I can give that. So that way Kubelet would run them. So I can give that just a YAML file via an API call, via file location, via an HTTP endpoint, or via an etcd bus. There are different ways I can give this YAML file for to my API, to my Kubelet to deploy the application for me. Okay. Then of course I can have a runtime of my own choice. Already talked about this part. What we covered just now. So kubeproxies does two jobs for me. One for getting the SL traffic come inside the cluster, and there's one more job where it would it will configure my pod communication. So I'll talk about that in some time. So just for now, kubeproxies for accelerated communication. Then once you have the base Kubernetes installed, you deploy some additional apps on top of it. It does not come on its own, like dashboard, logging server metrics. It does not come on its own. It would be coming, you have to install it separately. Okay. Okay. So with that, we'll move on to the how do we access the Kubernetes cluster. So if you have triggered the lab already, what happened is you would have already got a single node cluster. And if you do a kubectl get nodes here, you will see that it is configured a single node cluster for you, which is both behaving as a worker and master for you. So this would be sufficient for doing our hands-on labs. Yeah. So now what's happening here is once the cluster has been configured, because I'm not going how it has been configured and so on, because it's just a one-on-one thing. Assuming that cluster has been configured for you, right? Now, what you have here is when you configure the cluster, you have a file called kubeconfig. So if I have to show you. So once the cluster has been configured, by default at the location of .kubeconfig in your home directory, .kubeconfig, you will find a configuration file. This config file says how we are going to connect to your cluster. So assuming that you have configured cluster on cloud, AWS, Azure, wherever it is, right? From your laptop, you want to connect to it. You would require this kubeconfig file on your laptop. Now, by default, I'm looking at this location, but this can be any other location as well. So, for example, if I let's say if I move it from here, so .kubeconfig, I'll say I move to /tmp now. Now, my default file is not there, right? So, if I do kubectl get nodes, right, it is not going to work, correct? Because the config file is not there. So, kubectl is your CLI program using which you would connect to your Kubernetes cluster, correct? Or we can talk to the API. So I'll talk about how we can talk to the API as well. But this is a CLI program. This requires this kubeconfig file for you to connect to a given cluster. Now, because I have moved the configuration file somewhere else, I cannot connect to it. But at the same time, if I do export kubeconfig as an environment variable and point it to the location where the file is, it will again start working because I am now telling specifically where's my kubeconfig file is, correct? So either you put on the default location or you copy it anywhere else. As long as you have had the environment variable, we are all good. Make sense? Okay. Now in this kubeconfig file, if you look at, there are few different sections what we have. The first is called clusters. then we have users, then we have context. Now, in all these sections you look at, this is kind of an array or a map, right? This kind of a list here. So you can see here, I could have listed here multiple clusters as well. So cluster, let's say I have a cluster of dev, cluster of QA, and so on, right? So I can list every cluster location, right? This is an API server location. So every server has an API server, and this is my API server location is there. So I would mention like dev cluster, QA cluster, and so on. Similarly, I can have multiple users. Then once I have multiple cluster, multiple users, I connect them with the help of context. Okay. So context is a way using which you connect a user to a cluster. And then again, you can have multiple context. Which one to use now? That depends on current context. Okay. Does that make sense or confused a bit? So I can have multiple clusters I'm talking about. I can have multiple clusters. Then I can have multiple users. Correct? Sorry. I can have then multiple users. Correct? I can connect these user to a cluster with the context. And if I have multiple contexts, I'll choose the current context to connect with. Make sense? Any questions here? Okay. Hope all of you are clear. Okay. Then next thing we want to talk about here is something called as kubectl proxy. So I said that, right? The API server. So when we connect to our Kubernetes cluster, we connect to the API server. Correct? What I'll do is I'm just going to click on open ID here. This will go open an ID for me. So where I can have partitioned terminal here, just for IDs here. So what I'm doing now is I am running a command called kubectl proxy. Now this command I am running on my client side where I have the kubeconfig file. So if I run this command, what happens now is this kubectl creates a secure or a proxy between my workstation and my API server. Okay, it is creating a proxy between my local environment and the cluster, which means if I access this URL, correct, this is actually giving me the access. Sorry, not cat. Sorry, curl here. This is actually giving me the access to the what is happening? Okay, sorry. Okay, my config file is not found here. That's why. Okay, because I have moved it, right? Yeah, that's what I copied there. So I just run this proxy command here again. So this creates a tunnel between my workstation and my cluster. And now if I do a curl on this, right, you can see here, this is giving me the entire API server endpoints, right? So because I'm going to make a request to my API server, right? These are my different endpoints to which I can connect to, correct? So I have like /API, then /APIs, then come down, I have /health and many others as well, right? Now pixelize it one more time here. I'll go to the next section here. So what view you see there is like a list view. There's a tree view here, what I have. So here we have this /API, which we saw there, /APIs, then we have metrics, health, and so on. This we refer as a core API group. So /API is being referred as a core API group. Then we have /API, which is other API groups, right? Now under these API groups, we have versioning here. So we can have, let's say, core API group V1. V1 means stable version. Then in some cases, we can have a beta as well or alpha as well. So because we would be building these features, they would be available in stable alpha or beta endpoints. So if you want to connect of a topic of a resource beta feature, you'll hit the beta endpoint, correct? This is how they're being designed, right? That you have one API group, there you have versioning, and you can choose which one you want to connect with. So let's say if I want to work on a pod object, correct? I would hit the core API group, version V1 and the pod object. If I want to work on a deployment, then /APIs, then again I have a subgroup called apps. Then I have versioning here, V1, only V1 I have now. Daemon said deployment and so on. Correct? So there are predefined location or predefined endpoints to which you can connect to work on a given object. That is how they have been working. Okay. So if I look at if you just search for Kubernetes API reference documentation, right? You will find the entire API documentation of Kubernetes there. And you can see here like pod comes from the core API group, job comes from the bash API group. So there's a predefined location where a respective object is there. So now if I have to create a pod object, right? If I have to create a pod object, then I would hit the core API group. So when you say that I want to work on a pod object, I need to first come here, then here, and then here, correct? This is my tree view, right? It's my complete view. So when I say API version, I'm writing a YML file here. It can be JSON file as well to create my pod object, right? Now to create a pod object, I need to hit my core API group. So when I say API version V1 only, right? Which means I am mentioning here. This is like a shortcut or whatever you call it. So API version V1 means you are already here. Okay. Now, if you are here, you can work on pods, nodes, and so on. Then we'll say something called as kind. I want to work on a pod object. Correct. So I'll say kind pod. Then in the field of metadata, I'll give a name to my pod called my pod. I'll talk about namespace in a bit. So just talk about for a name my pod here. Then we have a spec. So a spec means you are defining desired state of an object. So you are saying that I want to have a pod, and in this pod I want to create this containers or these containers here. Again, it's an array here. I can have multiple containers here. Correct. So I want to hit the object of, I want to create a pod object with this configuration here. Okay. Any questions here? So let's create a pod if there are no questions here. Okay. Fine. So let's try to, now if you kind of go to this pod section here, so we'll find this pod.yml, which I was kind of referring here. I'll go it one more time here. So we are saying that go and hit core API group, work on a pod object, give a name to it. We are giving a label to it. I'll talk about what labels are in some time. It's like a tagging to your objects. Then we are saying, I want to define desired state of my object. So in this pod, I want to have a container, and container name is going to be this one. This is the image I want to use. And this is my port number. Okay. So now if I run this particular command here, you can type it, of course, but I'm just running the command by this. So, okay, it's already exists because I think I triggered this earlier. So let me just remove the pod for now, because I think I was showing you earlier. So I'll just run this command here, and you can see here, this pod is created now, correct? Now, and if I do get pods here, you can see this, my pod is in the running state. And if I do one more option here with some more option -o wide, it is telling you that pod has an IP address, which is this IP address that's running on the given node. So if I have multiple node clusters, will give me the different node, but I'm on the master node right now. And if I describe the pod, I can find additional info about the pod. Okay, I'm just going to wait here. Just want to make sure that you guys have done till here. Just say thumbs up if you are done till here, that you can list the pods, get pods -o wide. So next is, if I kind of now find out more info about the pod, so I'll run a command of kubectl describe the object type and the object name. So here object type is a pod and the object name here. So as you can see, I am getting other information here, like my pod here, the namespace. I'll talk about that in a few minutes. What's my pod's IP here? In this pod, what containers I am running here? I have the information here. Then there's something called as events, right? So what happened as I deployed this pod, right? So this got assigned to a node. Image is already there. Otherwise, the image would have got pulled in, and then my container is created, right? So I can describe the pod to find more information. And then if I do get pod -o YML, this is giving me the output in a YML format, or I can have -o JSON. will give me a JSON format. So I'm saying get pods minus o YML. So as you can see a spec, right? This spec field is of course bigger than what we have mentioned there, right? This has kind of got some default values as well. So a spec is the desired state which I want, right? If I come down, there is a field called status. That is the current state of the object. So when you look at any objects, spec is your desired state. Status is the current state. So then control what kind of match that states are matching there. Okay. To remove a pod, I can delete a pod here. My pod is gone. And if I do get pods here, nothing would be there right now. So far, so good. Okay. Now, suppose I want to deploy the pod with multiple containers.
Sir, one question.
Yeah.
I mean, putting up a command wide and describing a pod, what is the major difference, sir?
No, just a more options there, nothing else. Like minus o wide will give you more parameters there, right?
I mean, the command which is kubectl pod my pod -o YAML, that will give you all the YAML information.
Correct.
And describe will give you the exclusive information, sir. Is
Which
that
one?
The describe pod?
Yeah. It's kind of not on the same thing. It's kind of just a different view of the same thing with additional information, but information is common there. I can think of that describe and YML maybe same output, more or less. It's just a YML format so that you can format it better way. See, if you look at here in describe, you have the events, right? But
yes, sir.
In the YAML, you don't have any events. So there are some minor changes would be there. Yeah.
Yes, sir. You're right. Thank you, sir.
Okay. Great. More questions?
I mean, one question here, sir. How will we'll go ahead and determine the namespace here?
Okay, I'll answer that. So basically, if you describe the pod, you'll get it. But I'll talk about this. Just give me a few minutes. I'll talk about the namespace after this. So next is if I have a pod with multiple containers here, right? So a pod can have multiple containers. In the spec section, I would define this, right? Container 1, 2, and 3, right? So whatever containers I want to have. So if I deploy this, now if I do a get pods here, you will see it's saying ready 0 of 3, okay? So now this pod has 3 containers. That's why I'm getting 0 of 3. In the previous case, I got only 1 of 1 because there's only 1 container. Also, look at here, I have used the apply command instead of a create command in the last session, right? So create can only create the object for the first time and make changes on the fly as well. So if I have made some changes on my application, I want to reapply them on the fly, right? I can do that. So in general cases, we are going to use the apply command because can create and make change on the fly as well, right? So that's what we would be doing in most scenarios. So now my pods would be in the running state because all would have been pulled up. And if I want to remove the pod, I can again do a kubectl delete pod and the pod name. But here I'm saying delete -f in the YML file. Okay. Now remember, this particular command does not remove a YML file. It just removes the content or removes the object created from that particular YML file. So like here we are saying that in this YML file, I mentioned to create a pod called multi-container. So this would remove that multi-container pod for me and it won't be there anymore.
In the multi-container pod, we just eliminating the changes in the specs form. Am I right, sir?
We're just changing, because containers, we want to have more containers here, correct, yeah.
And these images are pulling from a Docker Hub repository.
Yeah, by default, yes, by default they are. But if you want to put from private, you just prefix that with
you have to give the location for the PVC, am I right?
Correct. Not the PVC, not the PVC, the private registry of yours, right? Suppose you have a registry at some location, right? Like registry.cloud.guru. So I'll prefix that here. That's all.
Thank you, sir.
And Nepindra, like the difference between the create and apply, like is there anything which gets recorded to playback means in etcd.
No, it's not like that. It's not like that.
Nothing to
See,
do with
again,
that.
information is done in the key value store anyway. When you do apply or create, right?
Yeah.
That is anyway stored in the key value store because it's a data state for you, correct?
Okay.
What you can change, for example, let's say I am adding a label on the fly, correct?
Okay.
So that would be a on the fly change.
Okay.
Correct. Yeah.
Understood.
Okay. Okay. So we'll look at the namespaces now, and then post that we'll take a 5 minutes break after that. So when you deploy the cluster or when you kind of have a cluster which is shared by multiple teams, you want to make sure that not one team is able to or kind of just take the resources and then consume everything on that cluster or there, right? So or just want to kind of enable the multi-tenancy environments. For example, you have a dev team, prod team, and so on, and you want to have different users go on a specific team and work there. So Kubernetes namespace is a way using which you can basically partition this cluster virtually. It is not the kind of a hard partitioning per se, but you are creating multiple virtual cluster on the fly. Like here, for example, I have a dev team and a prod team, correct? And so I can, and I was saying that on those teams, dev team can consume at max 4 GB of RAM overall. Similarly, prod team can go up to 8 GB of overall RAM. So I'm limiting the users of the dev namespace to go beyond 4 GB so that they cannot consume the entire resource of the system and so on. Correct. Also, the objects deployed are unique on a given pod are unique on a given pod only. So for example, my pod in the dev namespace is different than the my pod in the prod namespace. Correct. There are 4 default namespace what we get as we install the cluster: default, kube system, kube node lease, and kube public. In that, kube public and kube node lease are primarily used for cluster creation and bootstrapping, so we kind of ignore them. Kube system is a namespace in which Kubernetes run Kubernetes specific applications and so on. While for users like us, by default, we go into the default namespace. So by default, we all land up in the default namespace. So now if I kind of look at get namespace command here, you can see here, I can see 6 of them, 2 of them created by us for our lab purpose. But here, these 4 are there, which you can see. Now, as an admin, currently we are admins, we have the full access, and we can create new namespace as well. So I'm deploying a new namespace called test here. Now, while I deploy the applications, right, I can hard code my what do you call? So I can hard code my pod.yml file like this. So suppose I had this pod.yml file in the earlier section, right? So I can say that run this particular pod on the test namespace. I can hard code like this, but rather than hard coding, what we are saying is I would pass that kubectl create pod command and say -n test. So I deployed the namespace here, which currently doesn't have any pods running anymore, right? There's no pods in that namespace now, correct? But then if I do get pods, create pod and -n test, right? I'm saying that run that pod on the test namespace because there's no pod.yml. So let me quickly copy that actually from the other location. So I'll basically copy this into the namespace section. Yeah. Just have same YML file, you can apply it manually. I can do it manually for you as well. So we just need a file there. It can be anywhere, so it's not as a part of this, but I'll have it here. So as you can see here, I have this pod.yml file, same file which we had in the last section. And now I can do kubectl apply or create pod.yml -n test. So now this would deploy the pod in the test namespace. And if I do get pod, you can see here, I'm saying my pod in the test namespace here. And now if you describe this pod here, right? So kubectl describe pod, my pod -n test. You'll see here, because of course we are saying the -n test here, but if you look at even in the describe the pod, you'll see here where this pod got deployed and all those will come here, correct? And if I remove the namespace, automatically all the apps of that namespace will also go away. Because I'm removing my pod namespace, all the apps of that namespace will be removed as well. So now even my test namespace is also gone here. So I'm coming back to the normal, the other things. Yeah.
Best practice with regards to like when we are actually working with namespaces, Nipendra, like what you suggest, some tips or like some gotchas which needs to be careful? Means, for example, I'm working on a real prod or a real Kubernetes environment. So what should one consider or keep in mind when we are working with namespaces, basically?
Of course, you share the resource code correctly. That's one of the biggest thing, correct? Because
perfect.
If you don't do that, then somebody can take out, kind of consume that like infinite resource on the namespace. That can be an issue, right?
Yeah.
And of course, then when we are not covering in this topic, but when we create our users on the cluster, right? We want to make sure that our users are part of the given project itself, right? Rather than a dev user get access to prod cluster, right? Prod namespace. That can be a difficult thing, right? So those things will take care as a part of an admin, right? That you don't want people to go to a random namespace and deploy any apps there. You want to give them the permissions in a way. So currently we can do anything, but in the real world, the users are not admin in all the namespaces. So just take that of those things.
No, perfect. Yeah, makes sense. So one is for the users and also for the resources. We need to consider.
Yes, correct. Okay. Fine. So with that information, we are now going to next section here, which is application lifecycle management, in which you want to look at how we would deploy the applications in the way that it can scale up, scale down on demand. So we just saw right now the pod. Suppose if I would deploy 3 copies of my application, I would deploy 3 pods separately now, right? So they'll not be like a group together, and if one pod dies, automatically new pod comes as a replacement of that, right? So we want to kind of deploy these pods in a declarative way, and that's where we have this object called ReplicaSet, and ReplicaSet help me deploy these pods declaratively. So now currently here is an example of a ReplicaSet, in which we are saying that this is my replica set with the name, whatever the name I would give. I want to have 3 replicas of a given pod. So I want 3 replicas, desired count is 3. Current 3 of them are running, we are all good. But now let's say if one of the pod dies, automatically a replacement pod comes in place of it. Right? So as you can see, another pod has come now. And this is my ReplicaSet YML file, in which now we are not going to only v1. Now we are going to /APIs apps v1. So when you say apps v1, it means it's under /APIs /apps /v1 kind of a thing, right? So that's how it is. Kind replica set, define the replica count and define your pod template here. So I'll talk about this label selectors in few minutes, but for now, ReplicaSet would deploy X number of copies or replicas we have mentioned about this pod template, the pod which you have mentioned. Okay. So let's go ahead and deploy this ReplicaSet. Again, the same example what we have seen. Kind ReplicaSet, replicas, and I want to have 3 replicas of this given pod, right? So now if I apply this ReplicaSet here, this is going to create a ReplicaSet for me. Short form is RS for it. You can say get RS as well. And now you can see here, it would create 3 pods for me, right? So as you can see here, 3 pods have come here. So this is like replica set name and some hash value you have. Now, if I want to look at, if I delete a pod here, right? You'll see that automatically a replacement pod would come. This is getting removed. You can see here, right? As too fast, another pod has come in place of a replacement of this. So because we killed one pod, my desired count was still 3, current count was 2. A replacement pod has come and we got a pod with this new ID here. Any questions here? And if I remove my replica set, every pod would go away as well. Correct? Because yeah.
So like if your pod has not died, but for some reason, I mean, it is not working, that application is not working. So
that's a different thing.
Okay. So in your replicas, I mean, so in this case, it has to completely go off. Only then it will create a new one.
Correct. So what you're referring is a, let's say, failure of the health. Correct.
Yeah.
So what you're referring is maybe the pod is running, but inside the pod, the app has died. Correct. So for that purpose, we have a different thing called, you do liveness probe and the live health checks you can do there. So those are a different part which you'll configure. And though in that case, if the health check fails, then I would try to do the container restarts on its own to bring that up. Correct. But here in this case, it's kind of completely died for whatever reason.
Okay.
And Nepindra, if you see the YAML basically means in the YAML we see this selector match.
I'm going to explain that. In the,
okay.
Okay, so let's explain that in a few minutes. So let's do that. So here I'm going to again install it. So again, I'll have 3 pods created. Correct. Now let me deploy one more pod here. So let me get that pod created. So it would be in my other section. I'm just going to copy one more pod definition here. It's not Vim. Let me just copy it here actually. Copy. And I'll copy this /tmp here. Now here, I'm going to actually remove this label for now here. I'll copy this YAML file for you to consume also if you want to. So this is my current YAML file. There's some difficulty in copying here. I'll copy from here. As if you just want to copy it, you can do that as well. This is my pod.yml here. And now let's see if I apply it here. So kubectl apply -f/tmp pod. Okay, so now what we have is we have 4 pods running here, right? And we saw that for those 3 pods, right, when we deployed with the replica set here, this is my pod template. This is my pod template. So this is my replica set information. This is my pod template. In this pod template, I have defined the labels called app is equal to nginx. So 3 of these pods have a label app nginx. Okay. So now if I look at the command kubectl get pods, and I put an option here, --show -labels. So as you can see here now, in this case, when I run this command, right, you can see these 3 pods have a label app is equal to nginx, while the first pod doesn't have any label here because we are not given it, right? There's no label is being given here. That's why there is no pod in this case, correct? No label in this case. Now there's something called a selector using which I can select my objects. So first of all, these labels can be given to any objects, not just pods. I could label my different objects as well. And once I have labeled them, I could select on them. So now if I do kubectl get pods and -l for selection here, okay? So if I say, give me all the pods where the label app is set to nginx, right? Now you can see here, it is not going to list all 4 pods. It's going to list only 3 pods for me because only 3 pods have a label app is equal to nginx. Getting the point? Right? And now if I look at some more way, if I say, give me all the pods where app is not nginx, I get my pod. Correct? So this way, I can basically make some selection criteria. So I deploy different objects, and if I have labeled them, I can do a selection on them. One more thing, if I say, give me all the pods where there is a label called app, I don't care about the value, right? Just give me if they have a label called app. I get these again 3 pods there. So I can deploy these applications, give them a label and do a selection on them. That's what's happening in this case as well. So what's happening as the replica set gets created for the first time, it is saying that I want to have 3 replicas. 3 replicas of what? I want to have 3 pods under me if they have a label app is equal to nginx. Let me repeat again. I want to have 3 pods under me if they have a label of nginx, and if they don't have it, then create them with this configuration. So I want to create 3 replicas. I want to have 3 replicas for the pods if they have a label app nginx, and if you don't have them, create this one. That's when we don't have any pods created, 3 pods come up. So being said that, let me give an example to you. So what I'll do now is I'm going to label my pod which I have here, right? I'm going to put a label on this pod here. This is my new configuration of my pod.yml. I just added a label there. Yeah. So now this is the label which I have, right? Now if I deploy this pod.yml, correct? You will see that I'll have this pod here, and this also have a label called app is equal to nginx. So far, so good. Now what we'll do is we're going to apply that replica set what we had from the last step. So here what we are saying is I want to create a replica set, and I want to have 3 pods which have a label app is equal to nginx, correct? Right? And if they don't have it, create of this particular category. Okay. Now before I actually do, I just missed one point. I'm going to come back to it, and then I'll come back with this example again. So I'm just going to remove this particular pod.yml for now, but I'm going to come back to it just after this. But I want to show you one thing. So currently I have this ReplicaSets.yml. That's perfect. I'm just going to apply the file here. Currently I don't have any pods running here. Just to make sure that, yeah. I apply this ReplicaSets.yml here. Correct. And now if I do pods are there, perfect. Now if I do a kubectl get pod, the pod name, and I do -o_yml here. So I'm looking at the pod and saying, give me the pod in a -o_yml format here, right? Now if you look at when I do this thing and I do a less on this, so you can see here, it has something called as a field called owner reference. So I have a pod, and as I deploy this pod, which came under by the help of a replica set, you can see here, there is a field called owner reference, and it says that this particular pod is child of a replica set called nginx. Any questions here? Are you able to follow?
I have a question. I mean, I'm trying to follow, but you mentioned something like in the replica set, when you go from the up, right, you have the kind is replica set, the name of the replica set is nginx, and within nginx, you're saying I want to create 3 replicas in that replica set, and then the label of those 3 pods will be nginx, right?
Yeah, whatever app is equal to nginx we are giving.
Yeah, whatever in this particular case.
Yeah.
But you mentioned something before that if the label is not nginx, then you
correct. I'll come to that point. I'll come to that point.
Okay.
Yeah, I was still not. I'm sorry. I'll kind of skip to one point. So I'll finish that and come back to that point.
Okay.
So what I said right now is I'm just saying what I'm showing, trying to show it to you. Earlier I had no pods there. I deployed this replica set, which gave me 3 pods. Correct. Now I am referring one of the pod here by the get pod and -o YML format here. I had 3 pods now because of replica set. I am looking at one of the pod here in the -o YML format. And here you see that there is a field called owner reference being set. So now this pod is, because it got created by the given replica set, the owner reference is being set like that. Okay. It is saying that for this particular pod, the owner is replica set name nginx. Correct? This is clear to everyone? Yeah. Okay. Assume that there's no question here. I'm just going to do one more change here. I'm just going to open this pod, remove the label from here. This is my pod here. And I'm going to apply this pod again. Correct. Now I am going to look at the my pod in the -o YML format. Now, if you look at for this particular pod, there is no such thing called owner reference, which means for this particular pod, there is no owner is being set. It is an independent pod, which is like if you kill it, nothing happens. This pod just goes away because it is an independent pod for you. Okay. Now, why I'm talking about this particular point here, there's a reason for that for sure. I'm going to remove the replica set for now here. Remove replica set nginx, which kills my first pods here, which I have. So I just have only one pod running here. And currently I don't have any label to it. Correct? It doesn't have any labels being set here. Okay. Now I modify my pod.yml again. And here I basically add a label. Labels app is equal to nginx. Okay. So now I am adding a label in my app nginx. Oh, sorry, app in this particular pod here, my pod. I'm going to reapply my pod here. And as I reapply, you can see here, there is a label has come to my pod. So currently, I just have a pod which has a label app is equal to nginx. Done. Now I'm going to apply my replica set again here, right? Now my replica set, if I'm creating again, I'm saying that under this replica set, I want to have pods which have a label app nginx. And as you can see here, for this particular my pod, I have the label app is equal to nginx, which I'm looking here. Correct? What's going to happen now is, because there is a pod called my pod, which has a label app is equal to nginx. Also, it does not have any parent being set right now. There is no parent is being set, which means it's like an orphan pod. Correct? Then what's going to happen is my replica set nginx is going to take it as one of the child. Correct? And it is going to create only 2 new pods rather than 3. It's going to create only 2 more pods if we deploy our replica set. So let me show it to you. If I apply my replica set now, right? You now see that it basically creates only 2 new pods, not all 3. Are you following? And now if I describe my pod, you will see that owner field is being set. Because when my replica set came, it found the pod with app nginx. It has no parent, it has taken one of the child here and then moved on and just deployed 2 more new pods.
A question here. I mean, I don't know whether you'll discuss about this later, but
go ahead.
Now, what if there are 2 different users and by chance they gave the same name, but they don't want to be part of the same replica set?
You want the same label, right? You want the same
yeah. So there are 2 different users and they don't know each other and they create the same label app nginx. So what will happen? How to avoid that situation where then they will be part of the same replica set?
Yeah, of course. That's a problem, of course. So what happens is, first of all, that's why. So when you are working in a given team, right, you will be part of a given namespace, assuming that, right? So of course, we may assume that, okay, because we are part of a same team, we may know each other in a way, but let's keep this aside. But as a guideline, when you work in a team in a given namespace, you would basically choose the labels very carefully, right? So at least you'll have one of the unique label and selected here. So for example, in this particular case, I can have not just one label, I can have multiple labels here. Not just one, I can have multiple labels. Similarly, I can have multiple selectors, but at least one has to match here. So when I'm working on these label and selectors, I work on that I have some kind of a unique key, which I am giving it for my application only. That's a good practice to do it. But being said that, let's say if I now create one more replica set here, so let me just actually show it to you. So if I can now assuming that if I change the replica set name here, same which I opened earlier, I just give a name new here, right? Now let's see if I reapply my replica set now. Do you think that I'm going to have a 3-pod or a 6-pod now? Answer on the chat, please answer on the chat. Because I just changed my replica set name here, applied it again, it going to create a new replica set for me. My question to you is, now we would be having 3 pods or 6 pods there in the environment. Answer on the chat, please. 3, okay. 3, okay. So overall, we'll be having 6, right? Why? Because for the new replica set, right? The new replica set, when it tried to come up, right, it would see that, okay, there are 3 pods already, but they are having the label which I'm looking for. But these already have a parent, right? I cannot just fetch from somebody else, right? So because these pods are part of some other replica set, I cannot take them, which means I'll create 3 new. So even in this case, labels are same, I'm perfectly fine. Correct? But as a good practice, you basically want to put some kind of a unique labeling between your applications so that there's no confusion. Like as you can see here, it looks perfectly fine. It would work as it is. There's nothing happened here. Correct? But this can cause confusions and some kind of on and off situations. So rather than doing that, you choose the label selectors wisely.
Is there no internal mechanism in Kubernetes which can indicate the user that there are some pods which doesn't have a ownership, but they have the same app or the labels, and it's going to be included in the replica set? Do you want to continue or something like that?
No, there is nothing like that, but you can build intelligence on your own. It's like this is being said, it's not part of the base cluster, but as a cluster, as a cluster manager to a given environment, right? You can deploy some kind of a logic. I said that, right? It is very extensible, right? So if you want to build that, you can do that kind of a logic and build in.
Okay.
Build on your own, but it's not come by default, anything like that. Because this rule is very clear here, right? That what it's going to, as they say, is working here, but of course, cases are there which can become a problem. But if you go look at the next example called object of a deployment, this problem is also not there. I'll talk about that. Okay. So for
Nipendra, one question I had, sorry for interrupting. Why did not discarded the other 2 pods which were created? Because the replica state, it will try to match the current state, right?
Which we're talking about, the new one or the old one? This replica.
The older ones, that nginx-9r and that nginx.jbv.
These are pod names, correct? So these pods are already part of some of the replica set, right? Why would I want to take the ownership unnecessarily?
See, this is a different file you have created.
Yeah, just change the pod name, just change the different replica set name. Rest everything is same, but this name is different, correct?
Okay, so it should have discarded.
No. Why? It's a different. It's a new object, right?
Okay, so older one it does not discard.
That is still there. That's still the running. Yeah.
Okay. Go ahead.
Yeah.
I mean, if I understand the question, I think so. If I have a replica set.yml and I create a replica set, and after that, if I just update the same file and then apply it again, and if I change
the name is different, right? It's a different object altogether now.
No. I understand. What I'm trying to say is, if I have a replica set.yml file and I I create a replica set and I give a name, say ABC. Now I apply it, so it will create like a replica set name ABC, and there will be 3 pods within it.
Correct.
Now I go back, I update the same replica set YML, and then now I change the replica set name to XYZ, and I apply it. So that means that the file can be the same, but as long as I keep applying it with new changes, it will keep adding new
See,
pods.
what's happening at a high level, right? This YAML file has no role to play. What actually happens is this particular request, when you run the command, right? These command goes or sent over the REST API call to your API server, correct? So this file actually have no role to play at all, correct? What's happening is as you apply, it basically kind of makes a JSON request, like a payload to a thing, and then send across. Correct. So because change the name, when you reapply it, you're sending a new JSON data to the server, right? To apply it.
Yeah, got it. Okay. Thanks.
Okay, so I'm just going to delete all the replica sets for now. So I'll just say delete. Short form is replica set. I'll say -- all. This removes all of my replica sets as well. Okay. So with that, I'm going to move to the next object of something called as deployment object. Okay. Now, deployment object sits on top of replica sets. So in a way, when we do our app deployments in our cluster or wherever it is, typically we use the deployment object. We don't use the replica set to deploy the applications. We use the object of a deployment creation. So deployment object creates replica set for us. This would create pods for us. So I'll tell you why we need separation between deployment replica sets in few minutes. But for now, deployment object create replica sets. We will create pods for you. Okay, so let's understand that part for now. So let's go ahead and deploy a deployment object. So if you look at the YAML file, the YAML file is similar to the replica set here. It's just that we have changed the kind here. So kind is now become deployment object. And of course, as you apply it, the default values which get applied as this object is different than the replica set, of course. So you apply this YAML file, but as you apply it, some default values would automatically get attached to it, which we'll see. So now if I do a deployment creation here, this would do a deployment creation, which would create replica set for us, which would create pods. So deployment, replica set, pods. And you look at the naming here, right? This is my deployment name. And the replica set name is deployment plus some hash value. And pod name is replica set name and then some hash value. Correct? This is how they've been kind of connected. Deployment, replica set, pods. And of course, they'll have a parent relationship, all right. If you look at this particular pod parent, it will be replica set. If you look at the replica set parent, it will be the deployment as a parent. So if you just get the pod in a YAML format, the owner reference field will be set accordingly.
Sir, in deployment sets, are we creating 3 replica sets at the same time?
No, only one replicas. Replica set is only one.
I mean, when I'm looking to the output of Git deployment, I can see desired state as in 3. And
there are 3 replicas here for you.
Yeah, 3 replica sets. Yeah. And when replicas.
Not set. Set is only one. 3 replicas of a given application.
3 replicas of given applications.
Means pod.
Now here the label. One minute here. Match label con nginx.
And they have to match. They have to match. There's no other option.
Got it. Thank you.
Okay. Any other questions, anyone?
So in deployment sets, so it's just we creating a replica sets on the top of that.
It's just a deployment, not a set. Just a deployment object. Yeah. It just sits on top of a deployment, create replica, create pods. And I'll tell you why we need separation here in a few minutes. But for now, just look at this one. Deployment, create replica set, which will create pods for you. Okay. I'll tell you why we need a separate, like a layer on top of the replica set, just in a few minutes. Is everybody will deploy the deployment object, get the 3 pods running for that? Okay. Okay. Now, once we have this one deployed, Now we can scale up and scale down our deployment as well, right? So we can scale up and scale down our deployment as well. So here, yeah. So what couple of ways of scaling up and scale down the applications. One is I can always apply my YAML file. I can change my YAML file, reapply it. That's one approach I can have. What I'm saying is, if I look at my deployment configuration file, if I were to change, right, I can change in this YAML file, reapply it, which I'll do it in a few minutes, or I can do it from the command line here. So now if I run this command, this is basically changing the deployment desired state from 3 to 1. So as you can see, currently I'm running 3 pods because my replica count has been set to 3. Desired count is 3. But now I'm changing my replica count or my desired state from 3 to 1, which means 2 of the pod would get killed. As you can see, it happened just on the real time, right? I change my deployment count or the replicas from 3 to 1. So desired count has changed to 3 to 1, which means because I had 3 pods running, 2 would be killed and I am left with the 1 pod here only. Similarly, I can scale up as well. And you can see now 2 pods would be there.
So there's deletion of the other 2 replicas. They are dependent on some, like there's a user traffic on one application, and it will not kill it, right? Or how does it happen?
No, see, these are all similar applications, first of all, right? So there is so we don't communicate to the pods directly. We have a layer called service on top of it, right? Which I'll talk about the next section here. So service is on top of it, all the pods. So when you hit service, that traffic go to your pods. Okay. So from the end user perspective, hitting the service only. And this service kind of do a load balancing for me behind the scenes for multiple pods. So if one of the pod goes down, it would move the workload somewhere else. Correct. But being said that if your pod get killed, right? Now those pods can be killed, let's say for example, because of the power failure. You don't have a control, right? If the power goes down, everything goes away then and there itself. Correct. So first of all, when you're going to microservices world, you should be writing an application that you can fail any point of time and you can know how to bring it back. Correct. So that is not something Kubernetes kind of solve every problem for you. No. You as a developer also need to take care of those things, right? Because you're building microservices, should be okay that I can die any point of time. Correct. That's one case where your node in a power failure, everything is down. But for example, if you kill the pod, like very specifically, I want to kill a pod, right? In that case, what happens is no new traffic would be sent to the pod which is getting killed. At the same time, the killing pod would have some graceful period time to clear out whatever the cache and so on it may have. So we can configure that the default value something is there, but I can change that and say that, okay, if the pod is getting killed, I would do some of these things before it kind of get removed completely.
Okay. Yeah, but yeah. So when you're changing your replica count from 3 to 1, it just randomly selects the 2 pods and deletes them, right? Or
yeah, it actually basically
the logic or
yeah. It kind of deletes the last created one.
Okay.
Whatever the last creation one, will be created, will be removed.
Okay. Thanks.
More questions? Okay, great. So now let's go ahead and scale up to 10, for example. So I'm just going to make the count of 10 here. And scale my deployment to 10, right? So now I'll have 10 pods running because I have scaled to 10. Okay. Now all of these applications which I'm running, right? They're running the app version with the image of Nginx 1.9.1. So if I describe my pod here or kubectl get pod or describe the pod, whatever. You'll see that currently I'm using that image of Nginx 1.9.1. This is something to think about as a version V1 of my software. Now, assume that you are running 100 copies like that, right? You have scaled your app from 100 to 100. 100 apps are running continuously. Now, you want to move your app from version V1 to V2 for whatever reason, right? You want to upgrade to a new version, correct? So now, what are your options? Your option, one option is that whatever the replica set you have, right? You remove the replica set and bring a new one, which means you would be first deleting all the 100 pods and then creating the 100 pods again, which is going to be kind of a downtime case, right? Because you would first be deleting all the pods and creating again and so on, correct? But to overcome that, we have something called as rolling updates here. And that is where having the deployment with multiple replica set help here, or having the replica set and the deployment help. So this is my current state here, in which I have a replica set A, which is running all of my pods here right now. Now I want to move to I'm upgrading my app from V1 to V2, for example, right? So in that case, what's going to happen is the deployment creates one more replica set in parallel, which currently doesn't have any pod as of now. Okay. Now what's going to happen is this deployment pod pointed to two different replica sets. Then I'm going to create some pods in a new replica set and kill some old ones. Correct. This is called as rolling updates. So here I am not actually getting a downtime because my applications are all up all the time. But what may happen is some of my customer may see an old view, some of them may see a new view. But there is not a downtime in this application because I am upgrading with the help of rolling update strategy here. And eventually all of the pod would move to the new state here. Make sense?
Yes.
Okay. So let's go ahead and change our image version now. So I'm just going to run this flag here. So kubectl get replica set. I'll do a watch flag here, right? Watch flag means you just minus W means watch. I'm watching on this object, right? So I'm saying watch on all the replica sets here. Now I'm going to basically change that image version to, let's say, version of stable. Okay. So I changed the version of Nginx from 1.91 to stable version. And now I want to redeploy the deployment, right? So as I redo this deployment or reapply it, you'll see that there is going to be one more replica set would come in parallel, and you will see the this pod migration which I mentioned earlier. Okay, so let me apply this, and as you can see that a new replica set has come, correct? And in this we are deploying new pods here, killing some old ones, and this is how I'm going to continue. Eventually, all of my pods are now moved to the newer version, correct? And the older replica sets kind of gone cleaned up. It's got cleaned up now. So every pod what we had is now basically all the new pods are in the new replica set and older ones are gone. This is how the flow has happened, which I was mentioning earlier, with the help of replica set rolling update strategy. It's a default strategy as well. So if I do this here, so if I do a kubectl get deploy deployment name, and if I do -OYML here, what happened? Nginx deploy, I think not meant deploy. So as you can see here in this particular configuration, I have specified, where is it? Here, this one. The strategy is the default type is called rolling update. Of course, there are some parameters I'll talk about in a minute. But as you can see here, I had only one replica set here. Then as I did apply, I got new replica set. And now you can see that in the newer replica set, I'm creating some new pods, right? Desired count is 3. So this is desired current and ready state. So desired count is 3 in the new replica set. Okay. Now, how does this 3 number has come? So if you look at here, I currently have overall, I have 10 pods overall running. And if you look at in the strategy here, we have two things here, which are the type and two parameters here, which is saying max surge and max unavailable. Max surge means how many you want to create in the new replica set, which says 25%. It can be actual number also, but here giving a percentage. So 10 is my overall pods running, 25% is 2.5. So they'll all take a ceiling value. That's why the 3 number has come. So it depends on whatever the max surge you have given here, those many new pods will be created here. Correct? So in the new replica set, I'm getting 3 new pods created. At the same time, I'm saying max unavailable means 25%. Basically, same time I'm saying that how many I want to get removed, right? Older version. So here, again, the 10%, 20%, 2.5, here is the floor value, right? So here 2. So I'm changing my desired count from 10 to 8 for the first one because I'm trying to remove 2 pods there. Correct? So 10 has become 8 now. So this trend would continue until all of my pods are now being deployed under the new replica set. So we have done that. So now all of my pods would be of a newer version. So if I look at my new pods now, right? They would be all running the stable version of the application. kubectl describe pod name. If I look at the image name is changed as well. Correct? So this is what we have is a default strategy of the rolling update of our deployment. There's one more strategy here called recreate. Okay. Now the recreate basically simply means that you are going to first remove all the pods and then create a new ones. Okay. So recreate means that I'm going to first remove all the pods from the current replica set and then create the new ones. So in this strategy, I'm going to have a downtime. This is required when I don't have the liberty of running 2 different versions of the application at the same time. When I can't run this kind of thing that where one version is new, one version is old, I can't do that situation there. That's where I'm going to use the strategy of recreate. Then we look at, I think I talked about a bit on the label and selectors earlier. So let's just quickly kind of review it. So we can assign labels to any objects. So now labels can be given to pods, nodes, deployment, services, whatever object is there, we can assign labels to any one of them. So now here we are giving a label like release table, and then we have a release table or release beta. Then we have something called as my org.io/envdev or QA. So I can assign labels to my objects. Okay. Then I can do a selection on them, right? So I can do a selection on them. Here I'm saying that give me all the pods where release is set to stable, right? So as you can see here, this one pod and blue pod is a green pod or whatever color it is, but I'm saying that I'm loosely coupling my applications even if they have not come from a same deployment or different same pods, whatever is created. So as long as if I'm having a label which I'm looking for, I'll select them. I'm not saying that they have to be coming from a same object, right? No, I'm just loosely coupling them as per my requirements. So here I'm saying simply that select me all the pods where release is set to stable. I don't care from where they have come from. Correct? So there are 2 kind of selectors we have. One is equality based, other is set based selection. So equality based that you can say release is equal to stable and not stable and so on. Then you can say set based release in dev or in queue stable. So logical OR will not work with the equality based, but with set based you can do it. Correct. So there in equality based you can't do a logical OR, but so this is a typo here. Actually should come under only for equality, but this is how it is. Okay. So now let's look at an example of that. So I'll first remove my deployment, whatever I have running, so that I have a clean slate here. Sorry. It's been removed. Okay. Now for the example purpose, I'm going to deploy 3 pods here. Here, one pod has no labels here. This is just my pod with no labels. Then we have another pod here with tier front end release prod. This is another label. Other pod I have which has a label tier back front end beta or release is equal to beta. So I'm deploying 3 pods here. And if I look at the show labels, you can see that the label what I have got. Correct? Now, if I work on a equality based selection, so I would say now, give me all the pods where tier is equal to front end. So as you can see here, tier is front end set to first and third one. So those will be listed here. Correct? And I'm saying, give me all the pods where tier is front end and release is prod. So I'm just saying this one, third one, right? Then I can say that give me all the pods where tier is not set to front end. So tier is not set to front end, which in this case, a tier is not set to front end, which means it's only my pod here. My pod doesn't have that label. Yeah. Correct. And same I'm saying, give me all the pods where tiers value is given here. So you can kind of choose from different kind of combinations as per your requirements to get the right number of app or right listing of the app. Okay. Then we have this set based selection in which I am doing like a set operation you would know. So release in front end, right? So release in front end, we have somewhere release is either beta or prod, but not front end, which means for the first I'll not do anything because there's no pod in the default name which is a label release front end. Then I'm saying give me all the pods where release is beta or prod. So I'll get first and third one. Then I'm saying give me all the pods where tier is front end and release not in beta or prod. So I'll get some more things here. Or nothing is there. Okay, so tier in front end, and what I'm saying release not in beta and prod. So release of course in beta and prod. So I can't have anything. That's why I'm getting nothing here. Correct? And then I'm saying give me all the pods where tier not in front end and release not in beta and prod, which means this is going to give you this my pod.
Nitin, I have one question for you. The commands that you are using, all these commands, do we have any link or any cheat sheet? Because those are very informative commands. We are noting it down, but
these will learn as a practice there. So we actually published a cheat sheet earlier. I'll see if I can find and send across to you. So there is a village cheat sheet there. You can actually just search at Kubeflow cheat sheet, you may get it. Not from me. I mean, maybe you might get from ours we have published, or there may be somebody else who published also these things. Just practice, you'll get it. It's just a practice thing.
Yeah, no, we'll check.
Okay. Anyway, you have access for, I think, around whatever 4 months. I think I have given the access to you guys for this labs. Yes, this is there. And also now you can also combine the equality based and set based as well. So here I'm saying that give me all the pods where there is a label called component set to Redis, and it will be and here, and tier is set to cache, environment not to dev. So this is how you can kind of define different expressions, different equality and set based together and find a grouping which you are looking for. Okay. Then we have this something called as annotation objects, using which basically we can put properties to your object. So again, annotations are your key value pairs, but they are primarily used to put properties. So we don't select based on these annotation values or key value pairs. This is primarily set some kind of properties. So for example, you want to put a property of who is the shareholders, what's the on-call people ID, name, email ID, whatever. Or you want to say that, okay, how would I collect my logs, monitoring data, and so on. So you can put any kind of properties to your objects, which somebody else can kind of look at and perform something on top of it. So for example, the example which I gave, pointer to logging and monitoring, right? So for example, you want to say that, okay, do you want to enable monitoring for this app or not? So that can be a property, correct? So my log server would collect the logs only from the applications which would have this logging something enabled. Correct? Because eventually when you have to pay for per data injection and so on the server on those stuff. So you kind of control whichever you want to do, whichever you want to send and so on. So those kind of pointers can be useful for other purpose, not just maybe you, but annotations are there to see the properties of your objects. Then what we can do is we also have something called as field selectors. They also help me select. They also help us basically select our objects in a better way. So for example, I want to find out all the pods which are in the running state, right? So if you look at these pods, right? So kubectl get pods, nothing is there. I removed, I believe, everything. So let me remove a pod on the fly now. I believe we'll have a demo here. Yeah, so let me so this command, kubectl run nginx, and you give an image name and that image name. So this command just creates a pod for me on the fly, right? So I have a pod created now. And if I look at this pods, kubectl get pod nginx -OYML. You'll see here in this particular pod under the status, right? I have something called as phase is the running state, right? Suppose I want to select the pods based on this running, right? Or phase running state, right? So these are not the regular field which I am kind of working on. But if I want to select on those fields which I want to kind of query and so on, right? So I can query based on this field selectors here. So I'm saying, give me all the pods where status is the running state. Now I'm saying the next thing is, give me the pods from all the namespaces if they are in the running state. Correct? So these kind of field selectors kind of help me to do this better querying there. That's the whole idea about putting this thing further. Now let's say I'm deploying a new namespace here called V1. I deploy a pod also with the name of Nginx in that namespace. I'm saying give me all the pods from all the namespaces if they have a name set to Nginx, correct? So this kind of a query which I want to make, with the help of these field selectors, I can make it easily rather than kind of doing some other trick. This command can help me do these things in a better way. Okay. So next we look at the section of services, right? So far we have deployed these applications with the hello deployment object, and these apps were deployed on my environment perfectly. But now I want to expose these apps publicly or within the cluster and so on. So let's see what kind of challenge we'll face if we just use with the pods IP, right, and so on. So if I look at the service object, why do I need first of all? So suppose I have these pods running. Some of them are blue, some of them are green pods and so on, right? Now I have these pods IP address which are available inside the cluster, and my user can communicate to these pods, right? So these pods can communicate to, that's perfect. But now what happens is if a pod dies, right? So previously all the pods have an IP address, right? And I can communicate to the pod IP. But if the pod dies, new pod would come up, it would have a different IP address, right? So unless I go and tell my new user saying that a replacement IP is this one, correct? Or assume that if your app got scaled up or scaled down for whatever reason, right? You would have got new IPs for the pods or killed some all of them, right? So the IPs are gone anyway. So I have to keep telling my user in this scenario that this is a new pods IP and so on, which is a bit challenging, right? Like, of course, not impossible, but it becomes it makes things very challenging there. So what we do is rather than kind of accessing by them with the pod IP, what we do is we group the similar kind of apps together, right? Like as you can see here, we have a group of similar apps together. So we have a group of app blue and a group of app green, right? Now we would refer this group as a service, so that as a user, I communicate with this group only, and this group somehow load balances between my backend pods which I may have. So here, now I'm going to basically send a request to my, of course, the service layer. Now this is a service layer here, which has a service name. So I can give a name to this particular layer and a respective virtual IP. So this IP is not given to any interface per se. It's just like a firewall rule saying that if a traffic is coming on this particular service blue or this IP address, I'm going to forward it to my these pods behind the scene. Okay. So my user is no longer hitting the pods. It's hitting a group together. And when I hit the group, my traffic would go to the backend pods accordingly for the whatever the labels and selectors I have. So here I have labels, here I have a selector. Any questions here?
So even if the pod dies, then this when it is the request is coming, this labels will handle it.
Yeah, service is still there, right? Yeah, that's what I'm saying. Service layer is still there, right? So for
Right.
end user, service layer is not gone anywhere.
Okay. Understood.
Okay.
Yes. And I don't know how relevant is this question, but this is the concept will be same for the private cluster and public cluster.
Yeah, correct. It's the same thing. It's within the cluster. It's happening inside the. This is not
Inside
talking
the
about off
cluster.
the. It's outside the cluster only. It's going to be same irrespective of on-prem or on-cloud cluster. This is the part of within the Kubernetes cluster.
Okay, good.
Yeah. Okay. Great. So now one more thing here. We hit. So when you look at the service layer, right? In this service, we have this incoming port, and from this service, the traffic would go to my pods. So we refer this incoming port as a port here, but from the service, when it goes to the pod, we say it's a target port. So we hit the target port at the pod. So we hit service layer on the port, and from service, we go to the pod on target port. By default, they are same if you don't specify, but you can say that target port is different. So for example, you can hit port 88 here, but when you go to the pod, it'll say 5000 there. So you can do that if you need to, right? That is your Kubernetes or like service object here. Now let's look at a demo of this to understand in a better way. So there are different kind of service types we have. So one of them type is called cluster IP, which is a default type as well. So when you deploy the service object, you can say type. If you skip it, then by default it's cluster IP only. So this cluster IP is available only inside the cluster. The main thing to focus here is called selector here. That this service is going to select which kind of pods. Correct? So it is going to be app is equal to selector is equal to app is equal to nginx. So it is going to select all the pods which have the label app is equal to nginx. Okay. So here let's deploy an object and then we'll come back to this particular example. So now I'm deploying a deployment here, which if you already have running, you can have it. But here I'm doing a new deployment creation with the replica count only one. So I'm deploying one pod here. Okay. So again, for this particular pod, I would have the pod with the label of app is equal to nginx. Okay. Now I'm deploying a service here. In this service, I'm saying, so kind service, again, core API group, kind service. There is a label given here, but this label is no longer used for me because I don't worry about this label. Somebody else maybe select on them, whatever. What I'm looking here is a selector here. So this label is for the pod object, which I don't care. So you can ignore it. What you can't ignore is a selector. So what we are saying is this service is going to select all the pods which have a label app engines in the default namespace. And this is of service type called cluster IP. This is available only inside the cluster. Correct? So if I apply the replica set, if I apply the service here, you can see it's created. And if I do a get service here, you will see that there is a service name which I have referred. Correct? Automatically got a cluster IP here. This is my port number. So now, if within the cluster, if I hit this particular name, I go to this IP and so on. Any questions here? Are you able to achieve this? So typically all the database kind of apps would be of type cluster IP.
So does that mean we can always refer with the name as well inside?
Correct. That's the whole point, right? So what's happening is inside the cluster, you also get a DNS for free. In a way that's already configured there. So when you deploy a DNS server or when you deploy the cluster, a DNS server automatically gets created. So let me show you. So if
it will be created by default. Okay.
Yes. So if I look at kubectl get names, get service in the namespace of kube-system, you'll see here there is a DNS server running in your cluster, correct? With this IP address, right? Now, let's say if I deploy a pod here, I won't deploy a pod in kubectl run nginx is my pod name. Image is equal to nginx alpine version. So I'm just deploying a new pod here, correct? And if I do an exec, so I know what, so if you have done Docker exec earlier, right? Similarly, we can do a kubectl exec to go inside a pod. So let me give the command to you if you want to try it out. So I'm going to just create one pod now. And in this pod, we'll do an exec. I want to do inside the pod, so I'll say exec minus IT for the interactive mode and give my pod name and say shell, or I can say shell like this only, or I can say it can be --sh. So whichever works for you. So now I am inside the pod of nginx, correct? Now from this particular pod which I am in, I should be able to access my service which is running in my namespace with a given name. So as you can see, it's my service name. So if I do curl this particular thing, you can see it's going to serve my package to me, correct? As you can see here, if I just do an exec to my nginx pod, and if I do a curl on my just the service name, correct? You can see it's going to give me the page. Now, how it's happening is, as we know that we have configured a DNS server in the etc.conf file, correct? Now, when I give this particular name, right, what's happening here, this is getting converted into a complete DNS name. And what it is the service name dot the namespace name dot azure-cluster.local. This is the complete DNS or kind of say FQDN for your service in the default namespace. When I run this particular part, you get the same page though. And if I do a ping, the ping command is going to fail, but you'll see that the mapping is still there. So ping command has not been enabled, but as you can see here, this particular IP, this IP is making same, right? Correct? Are you able to follow, guys?
Yes.
So now, on a similar logic, let's say if I deploy an app, right? So if I deploy an app, in the so I'm deploying a service again, but in this case, I'm now creating a new namespace first of all. So create namespace dev, for example. Then I deploy the similar service here. Kubectl apply -f deployment and -dev namespace. Similarly, I'll deploy a service also there. Correct. So now I'll be having a deployment service like the dev namespace. So kubectl get service -and dev, and same I can do for pods as well and so on. Okay. So what happened in the previous case when I did a curl this, right? This basically served me the pages from the default namespace. As you can see here, that was my default qualified domain name, right? But now here, how I get the fully qualified domain name? If you look at how does the DNS work, right? Sorry. If I look at the DNS part of it, right? So what I want to continue just a minute. Yeah. So if I look at cat/etc resolve.conf file, so you can see here it basically first have the service name dot the namespace dot s.cluster.locals. This is going to give you the service access to the default namespace, correct? But now, similarly, as I said that, right, I deploy the app in the dev namespace, right? So if I were to kind of go over the namespace boundary, then I can say service name dot the namespace name. So I'll say that, go and communicate to the test. That's my namespace there. Sorry, dev namespace. Sorry, dev namespace. And then what was the next? Is dot svc. So it is not actually the hyphen. There's a dot here. Yeah, svc. What did I do wrong? Sorry, it's nginx hyphen svc. Sorry. Yeah, correct. As you can see here, now it is searching on the pod from the dev namespace, right? Because I said now you should go and list on the dev namespace applications now. As you can see here, now this IP and this IP, what is, no, I think I need to do the SVC, right? Yeah. This IP and this IPs are matching, right? Because I am able to connect to the dev namespace service here. Are you getting what I'm trying to convey? So we have a common DNS server running in the entire cluster, right? And as you deploy the applications, the respective DNS entry get into the DNS server. Every pod knows where the DNS server is, and that's how you can resolve it. Correct?
Yeah. Got it.
Got it? Okay, great.
So internally in the code, should we refer with the IP or with the
Name always,
name?
right?
Name we should refer, okay.
Yes, correct. That's
And namespace is always suggestible, right?
No, not suggestible. Whatever you have in the cluster, right? Whatever you deploy in the applications. Yeah, so this is the cluster IP which is available only inside the cluster. So what typically going to happen is, suppose in this case, our service blue is a public facing service, right? And service green is a database, right? So service blue can be a public service, while green can be internal service. So when I hit the when I hit the service blue from the outside world, the blue can talk to the green in the internal world, right? So always my database application kind of things would always be in the cluster IP mode only. Make sense?
So Nependra, the thing is, the applications which are need to be accessible from outside, you're gonna create the cluster IP, and for inside.
Yeah, then we're going to do some more things. So I'll talk about these remaining two stuff, right?
Okay.
That will be
for internal communication. For example, between this node 2 and node 3, you mean to say like it automatically talks, or we need to again create a service?
So no. So first of all, you are not talking about node 2, you're talking about pods. So suppose this is a blue app, right? This blue app, this is a blue pod, right? If the blue pod need to communicate to the green application, right? It is not that blue pod talk to the green pod directly. It'll go via service layer only. Correct? So typically, we have a service layer on top of pods, right? And we hit our service layer only, which would take me the different pods behind the scene.
Okay.
So, kind of
so that one can be cluster IP or node port, and another thing which you will explain now, basically.
Whichever you want to make it publicly, they will be of type node port or load balancer type.
Okay. Okay. And cluster IP, when does it comes into picture? Like,
see, cluster IP is here only, right? This is a cluster IP only, right? Which is inside the cluster. This is referred to the cluster IP.
Okay.
Which is available only inside the cluster. Okay. One more point I want to mention here. So this is, we talked about one role of kubeproxy to get the excellent traffic inside the cluster. kubeproxy plays one more important role here. It basically connects the services to the backend part. So what's the actual traffic? See, what's happening is whatever mapping you are doing here, right? This is all logical mapping in a way, but you actually need like a packet transfer, right? So when I kind of connect, right, I need to have a packet flow saying that if I'm hitting this particular IP, I want to go to these pods behind the scene. So they're kind of some kind of a networking rule which enables that. And that is what kubeproxy also help us doing that. So what kubeproxy does is, kubeproxy configures the firewall rules. I assume that you know firewall or IP tables on the Linux environment or anywhere. So kubeproxy basically configures a firewall rule saying that if you hit the cluster IP, if you hit the cluster IP, this IP, you would go to any of these pods behind the scene. So this is the network connectivity or how the packet would flow, right? It has also been configured by the kubeproxy on every node. So kubeproxy is available on all the nodes, as I said earlier. And this mapping, what you have, would also need to be done on every node, saying that if you hit this IP, I would take you to these pods behind the scene, any of them. Correct? This is again kubeproxy's job to configure it.
Nipender, I have a question here.
Yeah.
So what is the algorithm it uses? Ideally,
it's a random algorithm.
Okay, it is not a specific.
Okay. You can't configure it as well. It's a default one.
Okay, it randomly sends to the available pods.
Correct. Yeah. But it's not kind of try to just bombard to only one pod. It does it in a very decent way. So there's an internal logic, they have it.
Oh, okay. Thank you.
Okay. This is what we have as a type called cluster IP. Then we have, so this is only for internal purpose. But now let's say for kind of expose these apps publicly, right? So let me just quickly do one thing here. I want to quickly set up a cluster on DigitalOcean as well, so that I want to show you some more things. So meanwhile, I'll go that lab. This will also get over. So I'm just going to log into my cloud provider, and I'm going to create a service type of, I'm going to create a cluster here. So I'll go here, say create Kubernetes. And I'm going to create a very minimal cluster just for our testing purpose. This is how I'm deploying the managed cluster on DigitalOcean. So I'll quickly go here, choose my whatever the version type, the location, the nodes. I'll just specify very basic one and then just say hit button. So it's going to create the cluster for me. So let me kind of go back and explain you what node port is, and I'll come back here and show you a few things. Okay. So what we did earlier is how we have exposed, in the previous case, the service were available only inside the cluster. Now let's say I want to make my apps publicly available. So here I'm deploying the service type of node port here, right? So now in this case, I would basically create a service and say service of type node port here. And I can, so what happens to type node port here? One port is being blocked on all the nodes. So if you have run this Docker command, right, which says like Docker container run -p 8080, right? So typically if you have run this command of Docker, we don't have Docker installed here, but I'll just show you the command. So if you run this command, right, Docker container run -p, right, -d -p 8000 to 80, and let's say run nginx, right? So what this particular container would do is it's going to deploy the container of nginx and map a port 8000 with the port 80 of the container, correct? That is what it's going to do, correct? So which means 8000 is your nodes on the nodes you're going to hit. So similarly here in this particular case, I'm basically exposing a port on all of my nodes here. So I'm going to expose a port on all of my nodes here. And when I hit that node port, so when I say that I want to deploy my service blue of type node port, a port is being blocked like 8000 we saw on a single node. Think about the same 8000 is available on all the nodes. So it kind of exposed on all of my nodes. And when I hit my node's IP on the node port, correct? The traffic is going to come to my service layer and to the pods. It is not necessarily that I need to have a pod running on this third node because I am hitting that node. No. You can hit any of the node on the node port, and from there, the traffic would come to your service layer and to your pods. Correct? So let me show you the example here. So in our case now, in the case of service with the type of node port. So here what we're doing is we already have a deployment created, so we can skip that part. Now here we are creating a service of type node port here, type node port, and we are hard coding the port number here, right? Now this port number either can be hard coded, which should be between 30,000 to 32767, some ranges there. Or if you skip it, then from that range a random port would come up. So currently I have given a hard coded number here. So let me apply this. So this way I'm going to create a service of type node port here, which creates an internal cluster IP also, by the way. And now there is a mapping is being done here. So which means says that now if I hit my node's IP on the node port, right, the traffic is going to come to my service layer on port 80, right? So if I hit my node on the node port, I'll come to my service layer. As I said that earlier, right? I don't need to hit the node on which pod is running. So if I hit my blue service specific node port on this particular node, right, the traffic would come to the service layer, and from there the response would go back. Correct? This is how the thing is being configured. So now what I'll do is I'm going to find out my node's IP address. So if I run this command here, kubectl get nodes -oy, this gives me a node's IP address. And if I hit my node's IP on the port number, so if I do a curl node's IP 10.0.132 and port number is 31009, you'll see that I'm going to get the page here. Correct? Makes sense. So you now going to hit the node's IP in the node port, and then you get your applications. Now let's see if our cluster is up and running. So it's still, I think, get created, but let me download its kubeconfig meanwhile. Let me just refresh this page. Yeah, so I just got the kubeconfig file here on that other thing what I have. So now I'm going to go to this particular, for example, /tmp do config. So I'm just copying the config file of my DigitalOcean cluster, paste it here, set the environment variable, export capital Q config, point to /tmp do config. Yeah. And if I do kubectl get nodes now, it should give me 3 nodes if the cluster is up and running. Yeah, it's still only 1 node has come up. Let's give it a few seconds. I believe it would bring my other nodes as well. Again, I'll put a watch flag here. Well, yeah, so I see that now 2 nodes are up. Correct. So let me now deploy the service here. So if I'm going to, this is my other cluster, right? It's not my local cluster. This is my remote cluster on DigitalOcean. Correct. So I have got 2 nodes up and running. Third one also will be coming up. But meanwhile, I can deploy the application. So I'll go ahead and deploy my similar app. So apply -f, deploy. So I'm doing a deployment creation. Then I'll deploy my service here. So kubectl get nodes now. So nodes are up. kubectl get pods. Pod should be up as running as well. Yeah. And if I look at my server, it's also up, right? So we have got our app get deployed. It's available on the node port here. Now, how would I access it? I'm going to find out my node's IP. So I'll do kubectl get nodes -o wide here. So now you can see that I have a 3-node cluster. They have 3 public IP addresses, correct? So I can hit any of the node on the node port of 31009. So let me find out on which node the pod is running, and I'll hit the other node in that case. So if I do this get pods -o wide, so it's running on the node which is the 3rd node here. So I'll pick up my 1st or 2nd node's IP address, go to the browser and hit 31009. As you can see that your app is up and running. Make sense? So of course you can't do this DO example, but otherwise you could have tried it there.
Nipendra, the first thing which you did was the config exporting. Can you?
They're just kind of saying that I want to connect to my DO cluster now.
DigitalOcean cluster.
Correct. Yeah, correct.
Mm-hmm. So how do you get that kube config?
No, I just installed the cluster there, right? By making a create button here, right?
Mm-hmm.
And there's a way to download the file locally.
Download config.
That's it. Pretty straightforward, right? Yeah.
Mm-hmm.
So now my clusters. So in this, I'm running the cluster there. Okay. Now, what do you see that? Do you see any challenge? So I have made my app publicly available, right? Now, do you think that there's any challenge here or any issues do you see with this kind of management of applications?
So we don't get the domain, right? We are currently pointing it with the IP.
Correct.
So HTTPS is
HTTPS, even you don't want to tell your customer, right? Access my applications by the IP address, correct?
that is
correct. So currently the way we are doing it, by this way, correct? So, but I cannot create a mapping of this with a DNS name, for example, cy.com, for example, right? I cannot make it because the DNS name does not allow me to kind of map the IP and the port combination. I can only map an IP here, correct? Which means with the help of type node port, I cannot make a DNS name, correct? Unless I create another layer on top of that, which can be let's say a proxy or something like that. I can do in that scenario, correct? But not in the regular one, I cannot do it. This kind of a drawback of this thing. Got the point? If I look at next is, so this is of service type of node port. Then we have a service type of load balancer. So in this case, I can basically tell my underlying infra to create a load balancer for me. So currently, what's happening is we saw the type node port where I need to access the app by the combination of nodes type and the port number. Now here what we are doing is we are saying expose my applications on a load balancer. So this is possible only in the infra where my Kubernetes can communicate to my underlying infra and request a load balancer. Correct. So now here, if I am running an app in my Kubernetes cluster through which I can access my underlying infra and request a load balancer, then what's going to happen is my infra is going to give me a load balancer IP or a DNS name which I can access publicly on the internet, right? So similar thing, load balancer would create a load port service to the pods, okay? So now I'm going to deploy a service of type load balancer. So here we change the type of a load balancer, correct? So again, in this particular case, this would be in the pending state all the time because currently this private infra does not support the load balancer. But if I run the same command on my DigitalOcean cluster, right, where I have support of load balancer, what's going to happen is under my networking section, currently I don't have an LB here if I go. But when I apply my application on this particular DigitalOcean cluster, you will see that automatically a load balancer would come here. So let me do that. So kubectl apply -f load balancer. Correct. I've applied it, and now you'll see that automatic load balancer would come here. Come on, as you can see, it has come up, right? So now once I would get this load balancer, then I would just get an IP address which I can publicly refer or map to a DNS thing, and I'm all done. Make sense?
Yes. So SSL will be applied on the load balancer then.
Come again?
SSL certificates
No,
will be applied.
no. Unless you have configured. No, not like that. You need to kind of provision additional thing on top of that. So currently there's no SSL right now here.
But that provisioning will be done this via YML files, or it should be done on the here interface. Like suppose if
there are different ways to achieve this. Actually, there's no one answer to it.
Okay.
So somewhere LB can be done. Somewhere you can say I want to configure the pass-through SSL, or somewhere you have ingress. There are many other ways of doing it.
Okay.
So as you can see, kind of getting through, I will get an IP address. And once I have this IP address, my traffic would come to any of the node on the node port, service to the pods, correct? So just finishing up. Okay, let it come. Yes, it's been created now. I got the IP address. And if I have the IP address, you'll see that I have my page up, right? Pretty straightforward, right? I can just deploy any of my app on Kubernetes, make a load balancer, and this is available. Similarly, if I remove my load service here, automatically the LU would be removed from there. Right? So if I go here, this would be removed, automatically removed. Okay. Yeah. So now, do you see any challenge of type load balancer? I mean, we can deploy the app on type load balancer, but what do you see as challenge? Right? What kind of problem do you see here? Do you see any problem or not? First of all, if you see what it is.
One problem would be like we are stuck with the like particular hosting provider. Like if you want to, like you will have to use one single provider, GCP or digital. Which one you are using this cloud?
No, I don't think so. Again, there are different things. Then you have some of these GLBs and all those things. So those can be, I mean, taken care into account as another Istio service mesh layer kind of a thing there. Don't go there. But for now, what's happening here is, so currently I'm creating one load balancer per service, correct? Which means if I have 10 services, I'll deploy 10 load balancers, right? Which may be expensive in some cases, correct? Because you're on the cloud and so on, you have to pay for every load balancer you create, correct? If you're getting an IP address from them.
Yeah, and there would be some quota also for the external IP.
Correct. So those kind of things would come up. So that's where we have something called as ingress, which can help me do things in a better way.
So there you will provide the rules and all. Okay.
Yeah. So there we'll have, so there only we have one load balancer, and that can map it to different applications and so on.
Mm-hmm.
So I think the workshop, what we're doing on Istio, right? In the, I think, third week, I don't know, just look at the schedule there, I think the team would be covering that. What is that and so on. Okay. So that is something which I want to kind of cover in this training, this session. Any comments, any feedback you have?
A couple of things. Sorry, go ahead.
Go ahead. Sorry.
Only thing I want to know, this recording will be provided, and second, will the lab that we created, can we use it after the session, or will it it will be disabled?
No. So you have access to this content for 4 months, I believe. And the labs are there for 40 hours. As you saw that you have chosen number of hours, correct?
Yeah.
So until you finish 40 hours, it would be there. Correct. The recording we'll give it. We'll even publish on YouTube as well. That's what our plan is.
Okay. The recording, right?
Yeah, correct.
Okay.
Yeah, you can also give a course feedback here. There's a course feedback form is here. If you just fill it up, that would be really helpful. And also just want to highlight one more thing is on our Cloudiga website, we are also publishing different hands-on labs. So what we saw as we kind of deliver these trainings, right? Some of the content what we deliver is primarily focused on finishing some kind of TOC and so on. But then what we deploy, what we need in production, right? They would be more than what you just teach or being taught in the classroom trainings and so on. That's where we're kind of building these different hands-on labs. So they are complete on its own. So for example, one talks about a bit on HTTP further on Kubernetes, correct? So we kind of touch upon that in detail. So you can also go and practice these hands-on labs on your own. And also we are looking for contributors. So if you would like to contribute, help us to build more hands-on labs, suggest the topics and so on. So you can also suggest that, and we welcome if you want to author some of these content, which would be available to other people as well. So we already got a few authors onboarded who are building the content with us. But it's kind of, you can also do it, but it will give you more visibility and create more impact in the community. So that's something which you can think next. Anything else I want to cover? Yeah, such feedback I think put on the chat here. Yeah, sure.
One question I wanted to ask, like after this 101, do you have any, or if you can suggest, like what are the next, how to proceed if somebody wants to get into ML ops, right? You know, I mean, like, are you coming up with courses where you have machine learning and, you know, something on Kubernetes and something like that? Because I just wanted to understand, like, this is very basic, but then what's next for someone who wants to learn more, but specifically into ML ops?
So MLOps, I don't have an answer for that, but MLOps is something like that. So first of all, you need to understand more on Kubernetes terms, which we have not covered. I mean, because of time constraint and so on, right? So you need to kind of look at one of the full course, maybe which kind of help you out with, like, maybe prepare you for CK or CKAD, which kind of gives you an overall picture about it, right? So, like, of course, we offer these courses, and these are available at some prices that you can buy them. We also do some of these what you call, say, offline sessions, but we primarily go with and teach corporates and train their employees there rather than doing open batches. But if there's a demand, we'll do it. But otherwise, you have seen the platform, you have seen how we deliver. So the remaining content on the other courses are delivered like that. So you can take a call, and if you want to take these, or there are other sites available, Udemy and many others. So you can pick up whatever works for you. So that's something which I'll leave up to you. But especially for MLOps, I have not seen specific course there. But once you understood the basic concepts, MLOps will just like a piece of cake on top of that, or icing on top of that. Sorry. So just like once you understood that, MLOps would be also pretty straightforward on top of that. So I don't see any challenge per se.
Okay.
Specifically.
Okay.
Yeah. Okay, sounds good. And if you guys want to get in touch, I have shared my LinkedIn profile here. You just want to be in touch, I'll be happy to connect.
Thanks a lot, Nitendra. It was wonderful. And the last part, which for example, someone asked the question, I guess, about the ML ops. What needs to be done next? We missed it, I guess, some of the guys.
No, so actually for ML, I said that I don't have any specific input on that. I just want to say that first we need to kind of get aware of it, overall Kubernetes stuff in general, right? Like the, not say about the course, but I think that CK or CKD kind of give you a basic ground at what you need to know, right? On top of that, ML ops, I don't know anything specifically what you should be doing on top of that, to be honest. But I don't see any difficulty on that. Once you understood that concepts, ML ops will be just like something, some bit on top of that. Nothing to be worried too much about it.
Yeah. So the CKD or CKA, like that would give a good solid foundation.
For foundation would be there. So you can of course take my this thing, courses there. There's EDX courses there, or there is a course which we also offer. You can take them, or any other course is also fine.
Definitely. I'll look forward, and also I like to contribute for this to author some of the course on Cloud Yoga. I'll reach out to you.
Yes, they can not complete next week. They can be simple hands-on labs. They
hands-on lab,
too much courses there, because I know that everybody is building courses to difficult tasks. But
yes,
I mean, it will take a lot of time. It's not that difficult, you can't do it. It's just that it will take a lot of time, right? But if you have, like, let's say, a couple of hours in a weekend or so on, right? And you want to work on an object, pretty straightforward. And building content also pretty straightforward. I just want to show you quickly how you can build the content other than. So basically, once you come on board, we'll give you an author role, and then you can kind of simply come here. Okay, I just want to say that what topic you want to put in, and then you say that, okay, I want to have a hands-on lab. You choose whether it's a type of Linux or Kubernetes labs. And then you just kind of start adding content. It's like pretty much like a Notion thing, right? You just copy paste the content, you add, you can upload an image. So it makes the diagrams, easy learning and so on. Easily you can create the content.
That's pretty nice. Okay, super.
So let me know if you are interested to connect to
that. Sure.
Okay, I think.
Thanks, Nitendra. Thanks. You are a great tutor. A very effective session.
Okay, great. So look forward for other sessions also, and for the event.
I'm thinking about that, and we'll try to engage more.
Okay, sure. Okay. Thank you.